Welcome, curious minds and sleepy thinkers. You've found a soft place to land, a quiet corner where the whispers of time can drift gently into your thoughts, inviting a sense of peace and wonder. Tonight we're going to tiptoe into one of the most profound stories ever told, a saga that unfolds not in pages or chapters, but across billions of years. We will ask a simple question, yet one that holds the universe in its embrace. How well do we truly know the ground beneath our feet, the very home we call Earth? We often imagine our planet as a steadfast, unchanging blue marble, a comforting constant in the vast cosmic ocean. But what if we were to peel back the layers of time, not with a hurried glance, but with the slow, deliberate unraveling of a dream? What if we could see Earth not as it is now, but as it has been through countless transformations? This isn't a race through scientific facts or a demanding lesson. It's more like floating downstream on a gentle river, allowing the currents of history to carry us through landscapes that are both familiar and utterly alien. So lean back, let your breath slow, and allow your imagination to gently unfold as we embark on this quiet journey through Earth's ancient, mysterious past. Let us begin our journey, not with a sudden leap, but with a gradual descent into the profound depths of time so far back that the very concept of time itself feels as molten and formless as the nascent world we are about to explore. Imagine, if you will, being an ancient mariner at the edge of an uncharted ocean, looking out at a horizon where the sky and sea blend into an indistinct haze, promising both chaos and the whisper of creation. Our destination tonight is the Earth, as it was a staggering 4.5 billion years ago, a mere blink after its birth, a raw, untamed infant in the cosmic nursery, still swirling with the energies of its chaotic genesis. At this unimaginably early stage, our planet was not the familiar blue and green sphere we cherish today. Instead, picture a furious, swirling cauldron of incandescent rock, a vast, viscous sphere of liquid fire. It was a world entirely without solace, without solid ground, a place where gravity wrestled relentlessly with the fierce heat of its own formation. Imagine a giant, fiery breath exhaling from the very core of creation, and you begin to grasp the intense, overwhelming energy that was the young Earth. It was a realm where the very elements themselves were engaged in a primordial dance, a ballet of annihilation and formation, where no shape held for long, and every moment was a testament to raw, unrestrained power. The silence of space would have been punctuated only by the roars of volcanic eruptions, not as distinct mountains, but as vast fissures across the entire global surface, spewing forth plumes of superheated gas and liquid rock into the nascent void. The air, if one could even call it that, was a thin, fleeting veil, a mere wisp of hydrogen and helium, the lightest of gases, remnants from the swirling nebula from which our solar system condensed. It clung weakly to the nascent planet, a fragile breath easily stolen by the fierce solar wind, a relentless cosmic breeze that swept through the young solar system. This was before Earth had woven its invisible shield, its magnetic field around itself. Without this vital embrace, the sun's cosmic rays, sharp and unyielding, as ancient arrows pierced through the flimsy atmosphere, bathing the young world in a harsh, unyielding radiation. It was a time of vulnerability, a planet exposed to the full, untamed fury of its star, a canvas of pure energy with no protection from the brushstrokes of the cosmos. Any substance not firmly bound to the planet's gravitational pull, or those easily ionized by the sun's relentless assault, would have been simply stripped away, carried off into the interstellar medium, like fine dust in a strong gale. And as if the internal fires and external solar winds were not enough, the young Earth was constantly besieged, a cosmic drumbeat echoing across the void. Asteroids and comets, like countless cosmic pebbles, rained down upon its surface, each impact adding to its growing mass, a process we gently call accretion. Picture, if you can, a colossal ball of soft, warm clay, and with every passing second, more and more fresh, unformed clay is hurled onto it, each new addition molding and reshaping the ever-growing form. It was a violent growth spurt, a ceaseless building, each collision a tiny act of creation amidst the grand fiery crucible. The scars of these impacts were swallowed instantly by the molten surface, leaving no lasting marks, only contributing to the relentless fiery expansion. These collisions weren't mere gentle nudges. They were often titanic events, capable of temporarily reshaping the entire surface, sending seismic waves rippling through the liquid rock, causing eruptions that dwarfed anything seen today. The very act of forming was an act of constant violent engagement with its cosmic neighborhood, a perpetual bombardment that both destroyed and built, eroded and added. Yet these weren't the only dramatic encounters the young Earth experienced. In a past that was still quite recent for our fledgling world, there was a cataclysmic event, a collision of such immense scale that it defies our everyday understanding. A protoplanet, a world almost yet not quite fully formed, met Earth in a shattering embrace. Imagine two colossal cosmic dancers drawn together by an irresistible unseen force, colliding in a slow-motion ballet of destruction and genesis. From this profound impact, a new celestial companion was born, flung into orbit around its parent, our moon. This collision, often referred to as Theia impact, was not a gentle brush. It was a colossal glancing blow that ripped away a significant portion of Earth's early mantle, sending a colossal plume of vaporized rock and debris hurtling into orbit. This incandescent ring of shattered matter, a shimmering halo of incandescent rock and gas, slowly, painstakingly began to coalesce. Over tens of millions of years, like cosmic dust motes, drawn together by an unseen hand, these fragments gathered, cooled and fused, forming the familiar orb we gaze upon tonight. It was a birth of fire and fury, a testament to the universe's capacity for unexpected creation, even amidst cataclysm, leaving both Earth and its newly formed companion forever scarred, yet profoundly interconnected. The moon in its nascent form was much closer to Earth, looming large in the primeval sky, exerting gravitational forces far more intense than those we know today, a constant reminder of its violent origin. If any curious alien scientists, those gentle, quiet observers from beyond our knowing, had stumbled upon Earth in this raw, tumultuous state, would they have seen its potential? Would they have discerned the promise of life? The whispered dreams of blue oceans and verdant forests within that raging molten sphere? Perhaps not with their eyes alone, for the sight would have been too overwhelming, too devoid of the familiar. It was a world of extremes, a symphony of destruction where the very concept of life seemed utterly impossible. The surface, a churning inferno, would have been inhospitable to any form of being. We recognize a cauldron of unimaginable temperatures, pressure, and constant upheaval. Any nascent, fragile spark of potential would have been instantly consumed, like a single drop of morning dew falling into a roaring volcano. Yet for those with the deepest wisdom, those who understood the long arc of cosmic evolution, perhaps they would have sensed a hidden code, a universal blueprint beginning to etch itself onto this chaotic canvas, hinting at the complex systems that would one day emerge. They would see beyond the immediate inferno, recognizing the fundamental building blocks, the raw materials swirling and mixing, ready for the slow, patient work of transformation. Still, even amidst these ominous beginnings, like tiny unseen seeds carried on the wind, the whispers of profound change were already taking root. Riding silently aboard some of those inbound asteroids and comets nestled deep within their ancient frozen hearts was a special compound, a simple molecule that would eventually become the very lifeblood of our planet's future water. While science gently suggests that not all of Earth's water arrived this way, carried across the vast interstellar distances, many models point to a significant portion of it being delivered by these cosmic messengers, these silent, icy couriers. Imagine billions of tiny ice ships sailing through the cold, dark ocean of space, each carrying a precious cargo destined for a fiery, waiting world. Each impact, though violent, was also a gentle delivery, a microscopic offering of purity onto a canvas of molten chaos. These icy travelers, having formed in the cold outer reaches of the solar nebula, preserved within them the pristine primordial water from the very birth of our star system. As they struck the inferno of young Earth, their icy continent would have instantly vaporized, rising into the atmosphere, adding to the growing invisible reservoir above. According to one of these thoughtful theories, hydrogen ions, tiny charged particles from the solar wind, quietly impacted the surfaces of these wandering meteors. With each soft touch, they gently dislodged oxygen atoms hidden beneath the icy exteriors, and in that subtle interaction, water was born. This process, a delicate chemical dance occurring on the harsh surfaces of ancient space rocks, created pockets of the precious molecule, which then journeyed inwards towards the warmth of our nascent world. These frequent soft impacts, like countless tiny brushes on a cosmic canvas, gradually seeded the young planet with the precious liquid. Picture the Earth, a vast, thirsty being, slowly, almost imperceptibly, being quenched by these silent, star-born tears. It was a slow drip, 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 accumulating over millions of years, building the foundation for the deep blue mystery that would one day cover so much of our planet. This slow infusion of water, drop by precious drop, began to cool the fiery surface, allowing for the first hints of stability, the merest suggestion of a crust beginning to form. Then, as the planet, with its core still burning brightly, slowly began its long process of cooling, a grand reordering commenced. The heavier elements, like sleepy giants, began their slow, deliberate descent, sinking towards the Earth's incandescent heart, drawn by the immense pull of gravity. This process, a majestic internal ballet, gradually formed the distinct layers we now understand: the dense, fiery core of nickel and iron, the churning mantle of semi-molten rock, and eventually, the nascent thin crust that would become our solid ground. It was a vast internal alchemy, a separation of essences as the world began to sort itself from within, finding its own internal rhythm and structure like oil and water, slowly separating in a jar. Meanwhile, the lighter compounds among them, the newly delivered water, began their slow, graceful ascent, rising towards the turbulent surface. This lighter material, less dense and more buoyant, floated upwards, driven by the intense heat radiating from below like steam rising from a vast hidden boiler, seeking escape from the pressures of the deep. Volcanic eruptions, vast fiery exhalations from the planet's depths, began to spew forth other gases, carbon dioxide, ammonia, and even more water vapor, adding to the thin developing shroud. Imagine the Earth sighing, releasing these gaseous breaths into the nascent atmosphere, slowly, patiently building its invisible cloak. Each eruption was a grand gesture, a release of pent-up energy, pushing ever more material into the atmosphere, thickening its veil, changing its chemical composition. These early atmospheric ingredients, a potent blend of gases, began to interact, driven by solar radiation and the planet's own internal heat, slowly evolving into something more complex, something capable of holding heat, something capable of supporting clouds. This constant outgassing from the planet's interior was crucial. It was Earth beginning to breathe, exhaling the building blocks of its future self into the surrounding void. Eventually, the accumulating water vapor, like an enormous unseen cloud gathering over eons, would condense, leading to the gradual, deliberate formation of Earth's first oceans. Vast liquid cradles and the slow, complex weaving of its mature atmosphere. Picture the heavens, once clear and harsh, now growing heavy with moisture, the vapor accumulating like a promise, until the very air could hold no more. Then the rains began, not a gentle shower, but a deluge of cosmic proportions falling for millennia, carving out the first basins, filling the deepest depressions. These weren't mere puddles. They were the birth of great primordial seas, the first liquid embraces on a once entirely arid and molten world. These early oceans, warm and rich with dissolved minerals, would become the sacred nurseries where the first, most fundamental sparks of life would eventually flicker into being. The atmosphere, too transformed by the gases from volcanism and the presence of these vast water bodies, would slowly evolve into a more temperate blanket, gradually offering more protection from the harshness of space, softening the relentless glare of the sun, and allowing for the conditions necessary for complex chemistry to begin its patient work. So even if Earth in this raw primordial state was a perilous place, a realm of fire and fury, our gentle alien visitors with their long view of cosmic unfolding might have discerned a hidden potential, a quiet promise beneath the raging surface. Perhaps they would have sensed the faint nascent pulse of a world yet to be, and decided with a soft, knowing sigh to return once it had steeped a little longer in the vast cosmic oven. They would wait patiently for the next chapter of this grand slow-motion epic to unfold, understanding that true transformation often requires the deepest stillness, the most profound patience, a quiet trust in the slow, relentless grind of geological time. They might have left a tiny invisible marker, a gentle whisper in the cosmic wind, a promise to return to this tiny swirling jewel once it had found its rhythm, once it had begun to truly breathe. They would know with the quiet certainty of those who have seen countless worlds born and reborn that this fiery sphere was destined for something more, something utterly unique, a crucible not just of elements, but of life itself. The foundations for something miraculous were being laid brick by invisible brick in the heart of this ancient tumultuous chaos. Let us gently draw ourselves forward through the vast stretches of time, leaving behind the fiery cradle of Earth's infancy. We move now with the quiet grace of a dream passing through 2 billion years, as if they were but a few breaths. Imagine the cosmic clock ticking with an almost imperceptible slowness each tick, 1,000,000 years, allowing for profound transformations to unfold. Our alien scientists, those patient voyagers of the cosmos, have returned. When they last visited our world was a molten orb, a furious formless beginning. But now, as they approach again, 2.5 billion years ago, they find something astonishingly different, a world that has begun to whisper the secrets of its emerging identity. Instead of the blazing inferno, they are greeted by a landscape that our own scientists have come to call the pale orange dot. This name itself carries a quiet poetry, evoking both mystery and a nascent sense of familiarity. The molten chaos has yielded to something solid. A crust vast and unyielding has finally formed across the planet's surface. Beneath this newfound solidity, the Earth's core has with immense patience generated a magnetic field, a protective invisible embrace that now deflects the harsh solar wind. This shimmering unseen shield is like a gentle constant breath, holding the planet's newly formed atmosphere close, preventing it from being stripped away into the hungry void of space. Without this shield, the story of life as we know it could never have truly begun. The atmosphere itself has taken on a distinct character. It is rich with methane, a gas that when viewed from afar would have cast a mesmerizing pale orange haze over the entire globe. Imagine looking at a distant planet through a soft amber filter, or perhaps witnessing a perpetual otherworldly sunset. This wasn't the vibrant blue of our present sky. It was a more mysterious muted hue, a color of quiet transformation. It might have reminded our alien visitors of Titan Saturn's largest moon, which today still wears a similar enigmatic orange shroud. This methane-rich atmosphere acted like a thick, comforting blanket, trapping heat and contributing to the nascent planet's warming, setting the stage for the next grand act. And beneath this orange sky, something truly miraculous has unfurled vast oceans of liquid water. No longer vaporizing instantly upon contact with molten rock, the water delivered by ancient comets and outgassed from volcanoes has gathered in immense basins, forming primordial seas. Imagine endless expanses of warm liquid expanse, cradling the world, reflecting the soft orange glow of the sky. These oceans were born from relentless rainfall, a cosmic weeping that lasted for ages, filling the deepest valleys and crevices of the newly solidified crust. It was a baptism for the planet, washing away the last fiery scars and preparing the ground for what was to come. As our alien scientists look upward from these nascent oceans, they would notice a terrifyingly huge moon hanging overhead. It would be far, far closer than the gentle companion we see in our night sky today, appearing perhaps 10 times larger, dominating the heavens with its immense presence. Here's a quiet, humbling thought. Our moon has been slowly, almost imperceptibly, drifting away from Earth for the past 2.5 billion years, a gentle dance of separation that continues even now at a rate of 3.8 centimeters per year. This cosmic waltz will eventually slow, but not for another several billion years. So 2.5 billion years ago, the moon's immense proximity led to far stronger tidal forces in the oceans. Imagine colossal waves, far mightier than any storm we know, sweeping across the vast liquid plains. Their rhythmic pulse, a constant testament to the moon's overwhelming gravitational embrace. It was a world of powerful rhythms driven by this close, silent companion. While this snapshot of Earth is undoubtedly more Earth-like than the previous fiery vision to our gentle alien observers, it might have felt even more profoundly alien. This wasn't the vibrant, teeming planet they might have anticipated. Instead, Earth must have appeared as a barren, dreamlike world, a canvas of vast, featureless oceans under an orange sky, far closer in its surreal beauty to a Salvador Dalí painting than the bustling, vibrant world we inhabit. There were no grand mountains as we know them, no verdant continents, just an immense quiet expanse waiting for its next chapter to be written. Being experienced in the field of astrobiology, our alien scientists, with their gentle curiosity, decide to take some water samples from these vast, blue-green oceans. They are not looking for grand cities or complex civilizations, but for the most subtle whispers of existence. And what they find fills them with a quiet, profound excitement. The cause of this orange haze, the source of this peculiar beauty, is life itself. They discover photosynthesizing bacteria called cyanobacteria, tiny, unassuming architects of change. They are thrilled to find that Earth has, against all odds, developed life, even if it is in its most primitive, humble forms. These primitive bacteria are living in vast communities in the shallow waters, perhaps forming sprawling mats that stretch for miles. And through their simple yet profound existence, they are beginning to transform the very essence of the planet. They are slowly, meticulously releasing oxygen into the atmosphere as a byproduct of their light-gathering existence in an event we now refer to as the Great Oxidation Event. Imagine countless invisible tiny factories tirelessly converting sunlight and simple chemicals into the breath of a new world, one molecule at a time. This slow exhalation of oxygen, like a gentle planetary sigh, began to accumulate in the atmosphere, slowly, irrevocably altering its composition. As part of this colossal transformation, Earth slowly began to form a protective ozone layer. This invisible shield, woven from the accumulating oxygen, began to filter out the most harmful effects of solar radiation. Those piercing cosmic arrows that once bathed the young planet in their destructive glow. It was like the planet slowly donning a protective cloak, knitted from the very breath of its first inhabitants. This new layer would eventually become the invisible ceiling of life, allowing it to eventually venture beyond the protective embrace of the water and onto the harsh, sun-drenched land. The bacteria are also producing unusual rock structures, built painstakingly over countless generations, called stromatolites. These ancient layered formations are strikingly similar to modern ones found in places like Shark Bay in Western Australia, where cyanobacteria continue their slow ancient work. Cyanobacteria form stromatolites by cementing grains of sediment together with biofilms, or to put it more poetically, with microbial slime. Imagine tiny invisible builders, each secreting a sticky substance, trapping grains of sand and dust, slowly patiently constructing these layered monuments to their own quiet existence. Stromatolites are one of the key biosignatures that astrobiologists carefully search for on other planets, a potential whisper of life beyond our own. Although they can sometimes have non-biological causes, a closer look, a microscopic examination of their intricate patterns, often reveals the telltale signs of life's slow, persistent artistry. Without any significant competitors in this ancient watery world, the cyanobacteria reign supreme. They are the uncontested rulers of planet Earth, the quiet architects of its future. Using the abundant energy of the sun, they are converting carbon dioxide and water into vital nutrients, and in doing so, they are continually seeding the atmosphere with oxygen as a precious byproduct. Imagine them as the planet's first, most prolific gardeners, tending to a vast unseen garden, slowly transforming the very air that surrounds their home. Their presence has permanently altered Earth's atmosphere in ways that make our current way of life possible, setting the stage for the complex oxygen-breathing world that would eventually emerge. It was a revolution not of fire or force, but of slow, quiet molecular transformation, conducted by beings too small to see, yet too powerful to ignore. Enthusiastic for Earth's unfolding future, our alien scientists. Those patient cosmic observers decide to depart once more with a promise to return. They will come back not in a mere blink of an eye, but in another colossal leap through time, a journey of nearly 2 billion years. They will return when Earth has had even more time to evolve, to shape itself to tell another chapter of its quiet unfolding story. They leave carrying with them the profound sense of having witnessed a pivotal moment, a turning point where a planet once a fiery wasteland began its slow, deliberate transformation into a living, breathing entity, all thanks to the humble, persistent work of invisible, single-celled organisms. The orange haze, once a sign of a barren alien world, now holds the gentle promise of a blue future, a testament to the silent power of life's most ancient whispers. They understand that patience is the true currency of cosmic exploration, and that the grandest narratives unfold not in a rush, but in the deep, slow rhythm of eons. Now let us journey forward once more, gliding through another immense expanse of time. Our patient alien scientists, having marked their cosmic calendars, decide to return to Earth at a point approximately 650 million years ago. They are eager to witness the next grand transformation, to see how the planet once cloaked in a pale orange haze and teeming with the quiet transformative power of cyanobacteria has continued its slow, deliberate evolution. What wonders they might quietly ponder await them now, but what greets them is a sight that must surely test the very limits of their cosmic understanding, a scene so utterly distinct from their previous visits that it defies immediate recognition. Instead of the warm liquid cradle under an orange sky, they find themselves staring at what our human scientists have termed Snowball Earth. Imagine the last great ice age, the one that shaped our familiar landscapes, but amplify its cold 1,000-fold, strip away all warmth, and extend its frozen grip across the entire globe. This is the reality they would behold, a world entirely consumed by ice, a shimmering vast expanse of white and crystalline blue, stretching as far as the eye can see, from pole to pole, equator to equator. It's a vision of breathtaking, chilling beauty. The entire surface of Earth is frozen solid, locked in an unforgiving embrace of glacial ice. More astonishingly, even half of its total ocean water has succumbed, transformed from liquid fluidity into an immense, unyielding mass of solid ice. This wasn't merely a polar cap. It was a planetary cocoon of frozen silence. The Earth, once a fiery forge, then a pale, watery nursery, has now become a colossal, glittering sphere of ice, spinning slowly in the cosmic dark. Temperatures at the equator, a region usually bathed in life-giving warmth, would have plummeted to levels similar to those found in modern-day Antarctica. A brutal, relentless cold that defies the imagination. Our scientists, both human and alien, ponder what immense forces could have triggered such a profound and devastating global downshift in temperature. The universe, in its boundless mystery, offers several gentle whispers of possibility theories that dance on the edge of what we can fully comprehend. One quiet idea suggests a major volcanic eruption that, instead of warming the planet with greenhouse gases, spewed an enormous amount of ash and aerosols high into the atmosphere. Imagine a vast opaque veil woven from volcanic dust, spreading across the entire globe, stubbornly blocking out the sun's life-giving warmth, plunging the planet into a deep, unending twilight. This aerial shroud would have acted like a global dimming switch, chilling the world to its core. Another thoughtful theory turns our gaze towards the very life that had begun to thrive in the earlier oceans. The immense proliferation of those photosynthesizing cyanobacteria, those silent architects of oxygen, might have paradoxically contributed to this deep freeze. By tirelessly converting carbon dioxide from the atmosphere into their own bodies, they caused a vast reduction in atmospheric greenhouse gases. Imagine a planetary gardener so efficient in its work that it inadvertently pulled too much warmth-trapping air from the sky, allowing the world to simply exhale its heat into space. This reduction in the Earth's insulating blanket, like shedding too many layers on a cold night, would have allowed temperatures to plummet. And then there are the slow, rhythmic pulses of our own planet's orbital dance, what we call Milankovitch cycles. These are the subtle, long-term variations in Earth's orbit around the Sun, the tilt of its axis, and the wobble of its rotation. While these cycles typically influence the onset of ice ages in this ancient, more vulnerable time, they might have pushed an already cooling planet over a critical threshold, like a gentle, persistent nudge that finally sends a precariously balanced stone tumbling. Of course, it was quite likely a complex and elegant interplay of several of these factors, a cosmic symphony of cause and effect that amplified this global cooling, pushing Earth into its long, silent slumber. Interestingly enough, nestled beneath all this vast glacial ice, our alien visitors would discern the faint, ghostly outline of a single supercontinent called Rodinia. Imagine an enormous sprawling landmass centered primarily on the South Pole, its rocky contours hidden beneath a colossal unbroken shield of ice. However, given the immense unbroken glacial cover, our alien visitors would have struggled immensely to discern where land met ocean, where the solid crust ended and the frozen water began. It was a landscape of stark, undifferentiated white, a planetary canvas painted in shades of frost and silence. As a gentle side note, it's important not to confuse this ancient supercontinent with Pangaea, a much later, more famous configuration. The slow, relentless ballet of plate tectonics would eventually break apart Rodinia, allowing its fragments to drift and reform, eventually creating that later supercontinent in a few 100 million years. But for now, Rodinia lay sleeping buried beneath its icy blanket. Our space visitors, embodying patience and quiet wonder, would choose a landing site amidst the vast, endless glaciers. They would wander across this immense frozen landscape, their multifaceted eyes perhaps reflecting the endless white, amazed that this unyielding icy expanse was once a swirling incandescent sphere of molten rock. At first, a quiet concern might settle upon them. Surely they would ponder this harsh, relentless climate must have utterly wiped out Earth's fledgling life, those humble cyanobacteria that had begun to paint the oceans green. But life, as they would soon discover, has proven remarkably resilient, a quiet, persistent whisper in the face of overwhelming odds. Though the surface world was a frozen tomb, deep within the oceans, perhaps clustered around the fiery solace of hot hydrothermal vents, life clung on. Imagine these vents as black smokers, similar to those found today along the mid-Atlantic ridge, spewing forth superheated mineral-rich water from the Earth's fiery heart into the frigid abyss. Around these oases of warmth and chemical energy, the cyanobacteria would have persisted, forming resilient clinging mats sheltered from the global freeze. It was a testament to their adaptability, a secret garden thriving in the darkest, most challenging corners of the world. And even more remarkably, new life forms, tiny and unassuming, had begun to evolve. Our alien visitors might have detected the presence of newly evolved microbial life forms, such as various forms of red algae, tiny complex multicellular organisms, a whispered hint of the complexity that was to come. While truly complex multicellular life remained elusive, still a dream waiting to unfold, the very fact that life had found a way to not only survive, but also to subtly diversify amidst the planet's harshest freezing event so far was a profound testament to its inherent staying power, its quiet, unwavering will to exist. It was a silent promise deep within the frozen heart of the world that life would find a way, no matter the cost, no matter the challenge. At this point, I like to imagine our alien visitors engaging in a soft, gentle argument among themselves, a quiet debate reflecting the profound challenges of understanding Earth's ever-changing nature. The youngest and most temperamental of the group, perhaps a little impatient with the slow, dramatic turns of this planetary tale, might have let out a frustrated sigh. First, a lava ball. It might exclaim its articulated limbs, perhaps gesturing in exasperation. Then a barren bacterial playground, and now a ball of ice. Why do we keep coming back here? This planet is so utterly unpredictable. But the eldest of the group, possessing the deep wisdom that comes from observing countless cosmic cycles, would gently place a comforting arm, or tentacle or articulated limb of our preference, around its younger comrade. Patience, the wise alien elder would softly say to its impertinent partner, its voice like the gentle hum of distant stars. I have a feeling this planet is in for some major shakeups, transformations that will astound even us. Let's come back in another few 100 million years. I think it would add with a knowing, gentle glint in its ancient eyes. It will be worth the trip. They understood that the universe unfolds at its own pace, and that the greatest dramas are often those that require the longest wait, and so giving the planet ample time to transform, to shake off its icy shroud, and discover new forms of being, our alien scientists decide to depart once more. They will return during a period we call the Devonian, a distant echo in Earth's grand symphony, a time when the planet would begin to truly stretch its limbs and reveal a vibrancy hitherto unseen. They depart with a quiet sense of anticipation, knowing that the story of Earth is one of constant, breathtaking metamorphosis, a narrative whispered across eons forever, inviting us to wonder at its unpredictable beauty. They trust in the deep inherent forces that guide worlds, knowing that even the most profound slumbers eventually give way to vibrant awakenings. Let us drift forward once more, carried by the gentle currents of time past the profound chill of snowball Earth, as if waking from a long, deep slumber. Our patient alien scientists, those seasoned observers of cosmic unfolding, return now precisely as their elder comrade had predicted, to a world utterly transformed. They arrive in what we call the Devonian period, approximately 360 million years ago, and the sight that greets them is nothing short of astonishing. The planet, once a vast, silent sphere of ice, has not merely thawed. It has burst forth with life, vibrant and teeming, a symphony of new forms echoing across its very surface. The global temperatures have rebounded dramatically, generally warmer than those of the present day. Imagine the Earth sighing a deep breath of relief, casting off its frozen mantle. Scientists estimate that the tropical sea surface temperatures during this period ranged from a balmy 30 degrees Celsius, perfect for the burgeoning life, gently cooling to about 21 degrees Celsius later in the Devonian. This subtle temperature drop coincided with diminishing carbon dioxide levels in the atmosphere, a gentle planetary exhale linked to the increasing proliferation of plant growth, a quiet, powerful feedback loop between life and its environment. It was as if the Earth, having survived the profound cold, was now luxuriating in a warm, welcoming bath, nurturing the tender shoots of a new era. The single supercontinent of Rodinia, once hidden beneath layers of ice, has now begun its slow, majestic dance of separation. The titanic forces of plate tectonics, those unseen sculptors of continents, have worked tirelessly over eons, breaking apart the ancient landmass and forming multiple distinct continents. The largest of these, named Gondwana by our human geologists, was a sprawling behemoth covering the South Pole and extending across much of the southern hemisphere. Imagine a colossal jigsaw piece incorporating much of what is modern-day Africa, South America, Antarctica, Australia, and India, all still intertwined in a vast ancient embrace. It was an impressive landmass, a testament to the slow, relentless power of geological movement, subtly reshaping the planet's canvas. But for our alien visitors, the most dramatic and breathtaking change they witness is not in the continents or the climate, but in the very fabric of life itself. The oceans, once home to humble bacteria and simple algae, have undergone what we call the Cambrian explosion, a rapid and astounding expansion of biological diversity that occurred a little earlier, leaving its full flowering to be admired now in the Devonian. Imagine a silent, unseen artist suddenly, with furious inspiration, filling the empty canvases of the seas with an explosion of shapes, forms, and functions. The oceans are now teeming with all sorts of complex life, a swirling, vibrant tapestry woven from countless species. Our alien scientists might gaze down into these warm, inviting waters and see the armored, segmented forms of trilobites, ancient arthropods, scuttling across the seafloor like intricate living jewels. Clam-like brachiopods, with their elegant hinged shells, filter nutrients from the water, rooted to the seabed like ancient living flowers. But the most profound new residents are the complex marine vertebrates, the fish in all their astounding finned glory. These are not just simple swimmers. They are diverse, powerful, and utterly captivating, marking a pivotal moment in the story of life. Among the more fearsome specimens, our alien visitors might spot the colossal Dunkleosteus, a massive armored fish, a true titan of the ancient seas. Imagine a creature nearly 10 meters in length, its head encased in thick bony plates, a living primeval tank propelled through the water. Its jaws, formidable and crushing, could deliver an immense bite force, making it one of the apex predators of its time. Then there is Titanicus, another giant, though perhaps with a gentler disposition, feeding on smaller prey like krill and zooplankton, like a cosmic whale of the ancient world. Given the sheer scale and predatory nature of some of these fish, which might resemble great white sharks, crossed with armored submarines, our alien scientists, despite the invitingly warm waters, would wisely decide not to go for a swim. They would observe from the safety of their craft, respecting the raw power of this emergent aquatic ecosystem. Meanwhile, a revolution of an entirely different kind has swept across the continental crust. What was once barren, windswept rock has been utterly transformed by plants. Imagine the land once stark and desolate, suddenly adorned with a verdant living carpet, with no large herbivores yet in existence to graze upon them. Vegetation grows unchecked, unfurling into dense, sprawling forests that stretch as far as the eye can see. These ancient woodlands have over immense stretches of time produced a rich layer of stable, nutrient-rich topsoil, gently holding the land together, preparing it for even greater complexity. But these trees, these pioneers of the terrestrial world, would look very unusual to our modern eyes. They are not the familiar oaks or pines we know, but vascular plants related to today's ferns and some conifers. Imagine giant ferns reaching skyward, their fronds unfurling in ancient sunlight, or primitive cone-bearing trees, distinct from their modern descendants. There is also an enormous tree-like fungus called Prototaxites, which could stand some 8 meters tall, a towering, mysterious sentinel of the ancient forests. Very likely, These enigmatic tree-like structures are the fruiting bodies of far larger subterranean organisms. Their vast networks of mycelia hidden beneath the newly formed soil, a testament to the unseen intricate web of life that was taking root. The forest floor would have been a rich, damp tapestry of decaying matter and new growth, a complex ecosystem in its own right, and then a moment of profound significance, a slow, hesitant step that would forever alter the course of evolution. A few brave marine species have begun an astonishing transition. They have evolved limbs and are beginning to cautiously walk on land. Among them, our alien visitors might observe Ichthyostega, a rather charming four-legged vertebrate. Imagine a creature resembling a modern amphibian, its stout limbs and developing lungs allowing it to navigate the swamp-like habitats along the ancient coastlines, half in water, half on land. It's a creature of two worlds, caught in a delicate balance between its aquatic past and its terrestrial future. These tentative steps, these first clumsy forays onto the solid ground, represented an immense leap for life, a profound expansion of its domain, opening up vast, unexplored niches for adaptation and diversification. As our alien visitors gently prepare to depart from this vibrant Devonian Earth, they finally begin to grasp the immense ecological diversity and the temperate climate that will characterize so much of Earth's future. The planet, once a molten sphere, then a pale orange dot, then a giant silent snowball, now somewhat resembles the blue marble we know today, albeit with a different continental configuration and vastly different life forms. They can see the trajectory, the unfolding promise. Of course, other profound changes are yet to happen. A mass extinction event will soon decimate marine life, a sobering reminder of life's precarious dance with planetary forces. But this devastation will eventually lead to even greater complexity among the land animals that adapt and survive. Temperatures will again plunge, setting off the late Paleozoic ice age, a return to colder times before rebounding once more to warmer temperatures. And complex life will continue evolving in remarkable ways, weaving ever more intricate tapestries of being. Among the new species to emerge will be amphibians and some truly giant reptiles, creatures whose very name whispers of ancient power, dinosaurs. Our alien scientists might quietly ponder, when will they visit next? How far into the future will they choose to journey? Will they perhaps meet us, the distant descendants of those humble creatures that first began to walk on land? Will they exchange some intergalactic travel tips with our future selves, or marvel at the paths our own species has taken? I guess with a soft, knowing sigh, we'll have to leave that chapter of Earth's grand saga for another day, for another quiet contemplation under the vast star-strewn sky. But for now, let us savor the profound beauty and the astonishing vibrancy of this Devonian world, a testament to life's relentless, unstoppable unfolding. Let us journey forward once again, carried by the gentle, inexorable flow of time. Our intrepid alien scientists, having marveled at the vibrant, teeming world of the Devonian, decide to return for another quiet observation. They aim their gaze at Earth now, some 280 million years ago, a period we call the early Permian. A mere 80 million years have passed since their last visit, a relatively swift cosmic blink. Yet the transformations awaiting them are once again profound, shaping the very land beneath their feet and the winds above. The most striking geographical change, immediately apparent even from a distant orbit, is the grand, almost unbelievable assembly of the continents. No longer are there multiple separate landmasses drifting across the globe as they were in the Devonian. Instead, the continents of Euramerica and Gondwana, those vast ancient puzzle pieces, have slowly, relentlessly combined into a single colossal landmass. This is the mighty Pangaea, the largest continent that has ever existed on Earth, by a long, long way. Imagine every current continent you know, from the sprawling Americas to the ancient lands of Africa and Asia, all gently, inexorably drawn together, fused into one immense, singular entity. Its sheer scale is truly record-breaking, a geographical titan not likely to ever be surpassed. The formation of this titanic supercontinent was not a quiet affair. The collision of these ancient landmasses, a geological event known as the Variscan orogeny, unleashed powerful tectonic forces deep within the Earth's crust. Imagine colossal unseen hands pushing the very bedrock of the world together with unimaginable strength. This titanic squeezing and uplift created a new mountain range truly epic in its proportions, called the Central Pangaean Mountains. And how tall might these ancient peaks have been, our gentle guides might ponder. Our best estimates suggest they were comparable in size to the modern Himalayas, perhaps even surpassing the towering majesty of Mount Everest. Picture a vast, rugged spine of rock stretching across the heart of this colossal landmass, reaching dizzyingly towards the heavens. These towering mountains, far from being mere scenic backdrops, exerted a profound and complex effect on the entire climate of Pangaea. The Central Pangaean Mountains lay just beneath the equatorial rainy belt, a region where warm, moist air typically rises, bringing abundant precipitation. Our alien scientists would quickly discover the dramatic impact of these giant mountains on the entire continent. South of this immense range, the climate was dominated by a mega-monsoon system. Imagine relentless seasonal rains, so heavy and persistent that they would reshape the very landscape, carving deep riverbeds and creating vast ephemeral lakes. The air here would be thick with humidity, the skies frequently clouded, a testament to the colossal amounts of moisture being drawn in from the superocean. However, there was a stark and dramatic flip side to all this rain. The mountain range in turn cast an enormous rain shadow to the north, creating a huge arid desert in Pangaea's vast interior. Picture a parched, desolate expanse stretching for thousands of miles, where moisture was a rare and precious commodity. This phenomenon occurs when air travels over tall mountains. It moves upward, cools, and releases its moisture as precipitation on one side. By the time it crosses the peaks, the air is largely devoid of moisture, becoming incredibly dry and thirsty on the leeward side. We can see a modern echo of this effect in our own world, in the vast, desolate stretches of the Gobi Desert, which lies in the profound rain shadow of the towering Himalayas. Pangaea's formation is a magnificent example of how plate tectonics not only dramatically reshape the world's landmasses and oceans, but also exert an immense fundamental influence on its weather patterns, dictating where life can flourish and where it must struggle for every drop of moisture. Yet continental assembly was not the only factor shaking up the world's climate during the early Permian. The Earth was still in the latter fading days of an ice age that had lasted for tens of millions of years, an event known as the Late Paleozoic Ice House. Our leading theory for this prolonged cooling is that the explosion of plant life during the preceding Carboniferous period had significantly raised Earth's oxygen levels while diminishing its atmospheric carbon dioxide. This reduction in greenhouse gases led to a weakening of the greenhouse effect, allowing more heat to escape back into space. Imagine the planet slowly exhaling too much of its insulating blanket, allowing the cold to seep in. Milankovitch cycles. Those subtle long-term shifts in Earth's orbit and tilt also likely played a gentle yet crucial role, nudging the planet towards cooler cycles. During the late Paleozoic Ice House, vast glaciers had built up at the poles and in the higher elevations, blanketing significant portions of the globe in ice. By the early Permian, however, a subtle shift was occurring. The planet had begun to enter a slow, hesitant warming trend. The polar ice caps, those immense white crowns, were gradually retreating, shrinking back from their most expansive reach. Yet reminders of the Ice Age remained, with glaciers still clinging to most of the high-elevation mountain ranges, like stubborn patches of snow refusing to melt under the growing sun. So, between the complex climate disruptions caused by the formation of Pangaea, the mega-monsoons on one side, the vast deserts on the other, and the cooler-than-normal, but gradually warming global temperatures, the life forms on Earth had a truly immense amount of adjustment to make since our aliens last visited. It was a world of profound contrasts, challenging life to adapt to find new ways to thrive in conditions that shifted not just across continents, but across epochs. The formation of Pangaea, that colossal landmass, had also profoundly reshaped Earth's water bodies. It produced a single vast superocean that encircled the entire continent, a boundless expanse of water our scientists call the Panthalassic Ocean, or more poetically, the Universal Sea. Imagine an ocean so immense it occupied almost 70% of Earth's entire surface, a truly staggering body of water. Additionally, a smaller though still significant ocean known as the Paleotethys Sea existed to the east, nestled between the emerging landmasses. To gather more information, and if possible to see what mysteries lay beneath its seemingly endless surface, our gentle alien visitors, with their characteristic curiosity, decided to embark on a submersible dive. They carefully entered a specially designed vehicle suited for the profound pressures of the deep and gently descended into the vast, shimmering depths of the Panthalassic. As it turned out, the safety provided by said vehicle was much needed. While harmless trilobites and nautiloids, those ancient shelled cephalopods, still remained in abundance, gracefully navigating the currents Earth's oceans, had acquired some truly terrifying new inhabitants, creatures that would look utterly alien even to our modern eyes. Among these new formidable residents was one of the strangest predators ever to patrol the watery depths, Helicoprion. Imagine an 8-meter-long shark-like fish, but with an utterly bizarre, almost nightmarish feature, a complete circular wall of teeth embedded in its lower jaw, resembling nothing so much as a spinning buzzsaw. Most likely, this terrifying dental arrangement was an adaptation for tearing apart and sucking soft-bodied prey, perhaps ammonites or early fish, slicing them apart with gruesome efficiency. Our aliens had seen some strange creatures during their interstellar travels, observed countless forms of life across the galaxy. But this was definitely one of the strangest and utterly unique design born from the forge of evolution. And honestly, Helicoprion would look utterly alien to us too, a creature from a fever dream, defying our conventional understanding of biological form. It serves as a profound reminder that Earth in its ancient past was as rich with alien forms as any distant exoplanet we might hope to discover. This deep dive into the Panthalassic, observing these bizarre and beautiful creatures, sparked a contemplative thought in the minds of our alien zoologists. They understood that Earth was a different planet back then, a world whose conditions had sculpted life into forms we could scarcely imagine. They might ponder with a soft sigh of wonder that in our own solar system, moons such as Europa Ganymede and Enceladus may harbor subsurface oceans hidden from the harsh glare of space, potentially suitable for equally strange and unexpected life forms. The lesson from Earth's ancient past is a universal one. Life in its endless ingenuity can find a way to flourish in conditions that seem utterly hostile to us, taking on shapes and strategies that defy our expectations. Meanwhile, on land, as our alien explorers returned to the surface of Pangaea, insects had begun to flex some serious muscle. Imagine the very air buzzing with life, a vibrant symphony of winged creatures. There were all sorts of beetles scuttling across the newly formed soils, and more strikingly, Permian dragonflies, known as Meganeurula, extinct orders of giant dragonflies. Just imagine a dragonfly with a wingspan about the size of common seagulls, its iridescent wings beating with a powerful hum, hunting smaller prey through the warm, humid air. It's a vision of a world where arthropods truly ruled the skies, a silent ancient kingdom of chitin and wings. Another frankly bizarre newcomer to the terrestrial scene was Diplocaulus, an early amphibian with a distinctly boomerang-shaped head. Picture a creature with eyes set wide apart on the tips of its broad flattened skull, navigating the ancient swamps and waterways. Look at how fascinating these Earth aliens are. Our extraterrestrial xenozoologists might exclaim to each other, their voices filled with quiet awe. They marveled at the sheer inventiveness of terrestrial evolution, producing forms so utterly removed from anything they might have seen on other worlds, yet so perfectly adapted to Earth's unique shifting conditions. But by far the most interesting quadruped of the early Permian, drawing the longest and most contemplative gaze from our alien observers, was the Dimetrodon. Although it is often mistakenly identified as a dinosaur in the popular imagination, this 2 to 4 meter sail-backed predator was actually a synapsid more closely related to modern mammals than to reptiles. Believe it or not, that distinctive sail along its back, a magnificent structure supported by long neural spines, could have been an ingenious adaptation that predates the transition from exotherms, animals that absorb heat from their environment, like modern reptiles, to endotherms, which regulate their temperature internally, like U.S. warm-blooded creatures. The Dimetrodon's sail contained a complex network of blood vessels strategically positioned to absorb the sun's warmth. This allowed it to raise its body temperature more quickly in the sunlight, gaining an advantage over its slower cold-blooded prey in the cool mornings. It was an early step towards true temperature regulation, a critical evolutionary innovation on a planet experiencing all kinds of climatic changes, especially those brought about by the formation of Pangaea and the lingering effects of the Ice Age. This ability to regulate temperature would certainly have been advantageous, granting it a metabolic edge, allowing it to be more active for longer in varying conditions. It's a truly wonderful illustration of how much living organisms can and indeed must change in order to survive. Our planet's climate is like a complex living system, full of inputs from geological forces and solar energy, with the biosphere as its corresponding adaptive output. Planets like ours truly dictate what sort of life can exist on them. And interestingly, as a planet changes over time, the type of life it can support also changes, constantly adapting, constantly refining its forms. Impressed by Earth's remarkable development, its ceaseless capacity for adaptation and transformation, our alien scientists decide to return in another 100 million years. They are filled with a quiet sense of anticipation, eager to witness the next great chapter in this planet's astonishing saga. Unbeknownst to them, however, they will miss a moment of profound, devastating significance, the largest extinction event in Earth's entire history, a cataclysm that will utterly reshape the very fabric of life. It is not the asteroid that eventually claimed the dinosaurs, but a far more sweeping and catastrophic event, one that would redefine the boundaries of planetary resilience. Having quietly observed the colossal assembly of Pangaea and the profound climatic shifts of the early Permian, our alien scientists, those gentle chroniclers of Earth's grand story, decided to delve deeper. Their previous orbital views and land excursions offered a glimpse, but to truly understand the planet's burgeoning life, they needed a closer look, especially into the vast encircling waters of the Panthalassic Ocean. This immense body of water, known also as the Universal Sea, represented nearly 70% of Earth's surface, a staggering liquid expanse that held secrets yet untold. With a soft whir, their specialized submersible designed to withstand the crushing pressures of unimaginable depths gently descended into the Panthalassic. The light from above slowly faded, giving way to the inky blackness that veiled the ancient abyss. As they slipped further into the silent, cold embrace of the deep, a profound sense of anticipation filled their craft. The safety offered by their vessel, as it turned out, was not merely a precaution. It was an absolute necessity. For while familiar, relatively harmless creatures like the trilobites, those ancient armored arthropods, and the graceful nautiloids, distant relatives of modern squid and octopuses, still navigated these primordial currents in abundance, the Earth's oceans had also given rise to some truly terrifying new inhabitants. These were creatures born of evolution's wildest dreams, utterly alien in their design, patrolling the watery depths. Among them, floating silently in the deep, our alien explorers encountered one of the strangest predators ever to patrol the watery depths, the helicoprion. Imagine an 8-meter-long shark-like fish, a formidable hunter of the ancient seas. But its most astonishing feature, a detail that would send a shiver down the spine of any terrestrial observer, was a colossal circular saw-like whorl of teeth embedded within its lower jaw. This was not a conventional set of teeth. It was a spiraling, perpetual dental conveyor belt, constantly growing and pushing old teeth forward. Most likely, this terrifying dental arrangement was a specialized adaptation designed for tearing apart and sucking the soft-bodied prey of the time, perhaps ancient squid or large fish, slicing them apart with gruesome efficiency. The sight must have been mesmerizing and unsettling all at once, a living buzzsaw of the deep. Our aliens had seen some truly bizarre creatures during their interstellar travels, observed countless forms of life across the galaxy, but this was definitely one of the strangest and utterly unique design, born from the forge of evolution's endless experimentation. And honestly, the Helicoprion would look utterly alien to us too, a creature from a fever dream, defying our conventional understanding of biological form. It serves as a profound reminder that Earth in its ancient past was as rich with alien forms as any distant exoplanet we might hope to discover, a testament to the boundless creativity of natural selection. As they silently observed the Helicoprion disappearing into the gloom, a contemplative thought rippled through the minds of our alien xenozoologists. Earth, they mused, was truly a different planet back then, a world whose unique conditions had sculpted life into forms we could scarcely imagine today. They might ponder with a soft sigh of wonder that in our own solar system, moons such as Europa, a frozen shell hiding a vast liquid ocean beneath. Ganymede, the largest moon in our solar system, suspected of harboring multiple ocean layers. And Enceladus, with its geysers of water vapor erupting from its south pole, all suggest the possibility of subsurface oceans. These hidden worlds, shielded from the harsh glare of space and the vacuum of their environments, could potentially harbor equally strange and unexpected life forms, evolving under conditions entirely different from those on Earth's surface. The lesson from Earth's ancient past, they would realize, is a universal one. Life in its endless ingenuity can find a way to flourish in conditions that seem utterly hostile to us, taking on shapes and strategies that defy our expectations, a constant dance between possibility and adaptation. The deep cold pressures, the absence of light, the unique chemical compositions, all these could be the midwives of entirely new branches of the tree of life, branches we are only just beginning to conceptualize. Meanwhile, back on land, as our alien explorers ascended from the deep and returned to the vast expanse of Pangaea, they found that insects had truly begun to flex some serious muscle. Imagine the very air buzzing with life, a vibrant symphony of winged creatures, far larger and more dominant than anything we typically encounter today. There were all sorts of beetles, scuttling across the newly formed soils, diligently performing their quiet, unseen work. And more strikingly, they encountered Meganeurula, an extinct order of giant dragonflies, not merely large, but truly immense. Just imagine a dragonfly with a wingspan about the size of common seagulls, its iridescent wings beating with a powerful, almost audible hum as it zipped through the ancient air, hunting smaller prey through the warm, humid atmosphere. It's a vision of a world where arthropods truly ruled the skies, a silent ancient kingdom of chitin and wings, a testament to the sheer scale that early terrestrial arthropods could attain in a world with higher oxygen levels and fewer large airborne predators. The rustle of their wings, the delicate clicking of their exoskeletons would have been part of the constant soundtrack of this ancient world, a counterpoint to the distant geological rumblings. Another frankly bizarre newcomer to the terrestrial scene, one that would undoubtedly capture the attention of our alien xenozoologists, was Diplocaulus. This early amphibian possessed a distinctly boomerang-shaped head, a truly peculiar anatomical feature that made it instantly recognizable. Picture a creature with eyes set wide apart on the tips of its broad flattened skull, allowing it an almost panoramic view as it navigated the ancient swamps and waterways. Its flattened body and wide head likely aided in hydrodynamics, perhaps helping it burrow into soft mud or ambush prey from below. Look at how fascinating these Earth aliens are. Our extraterrestrial observers might exclaim to each other, their voices filled with quiet awe, a shared sense of wonder at the boundless forms life could take. They marveled at the sheer inventiveness of terrestrial evolution, producing forms so utterly removed from anything they might have seen on other worlds, yet so perfectly adapted to Earth's unique shifting conditions. A silent, ongoing experiment in biological design. But by far the most interesting quadruped of the early Permian, drawing the longest and most contemplative gaze from our alien observers, was the Dimetrodon. Although it is often mistakenly identified as a dinosaur in the popular imagination, due to its somewhat reptilian appearance and imposing size, this 2 to 4 meter sail-backed predator was actually a synapsid. This means it was more closely related to modern mammals than to reptiles, a fascinating twist in the ancient story of evolutionary lineages. Believe it or not, that distinctive sail along its back, a magnificent structure supported by long neural spines extending from its vertebrae, could have been an ingenious adaptation that predates the critical transition from exotherms, animals that primarily absorb heat from their environment, like modern reptiles and fish, to endotherms, which are capable of regulating their temperature internally, like US warm-blooded creatures. The Dimetrodon sail, a remarkable biological innovation, contained a complex network of blood vessels. Strategically positioned to catch the sun's first rays in the cool Permian mornings, this vascularized sail allowed the creature to rapidly absorb warmth, effectively solar charging itself. This meant it could raise its body temperature more quickly than other cold-blooded creatures, gaining a significant advantage over its slower cold-blooded prey in the often chilly early hours. It was an early crucial step towards true temperature regulation, a critical evolutionary innovation on a planet experiencing all kinds of climatic changes, especially those brought about by the formation of Pangaea and the lingering effects of the Ice Age. This ability to regulate temperature would certainly have been advantageous, granting it a metabolic edge, allowing it to be more active for longer in varying conditions, providing a crucial survival advantage in a world of shifting temperatures. It's a truly wonderful illustration of how much living organisms can and indeed must change in order to survive. Their very bodies become living instruments, finely tuned to the rhythms and demands of their environment, a testament to the endless flexibility of life. Our planet's climate, the aliens observed, is like a complex living system, full of intricate inputs from deep geological forces, from the distant sun's energy, and from the very life that calls it home. The biosphere, that thin, vibrant film of life across Earth's surface, acts as its corresponding adaptive output, constantly responding, constantly reshaping itself. Planets like ours truly dictate what sort of life can exist on them, exerting a profound selective pressure that favors certain forms over others. And interestingly, as a planet changes over time, undergoing its grand geological and climatic cycles, the type of life it can support also changes constantly, adapting, constantly refining its forms, a never-ending dance of co-evolution. The Dimetrodon sail was a beautiful example of this intricate relationship, a creature literally wearing its adaptation to the world's changing climate on its back. Impressed by Earth's remarkable development, its ceaseless capacity for adaptation and transformation, our alien scientists decide to return in another 100 million years. They are filled with a quiet sense of anticipation, eager to witness the next great chapter in this planet's astonishing saga. They would no doubt have made predictions about the future of the Dimetrodon's lineage, perhaps imagining a world where sail-backed creatures might dominate. Unbeknownst to them, however, they will miss a moment of profound, devastating significance, a cosmic turning point that would utterly reshape the very fabric of life on Earth. They will miss the largest extinction event in Earth's entire history, a cataclysm that will dwarf even the impact that claim the dinosaurs. A sobering reminder that even the most dominant forms of life are but temporary residents on this ever-changing world. It is a mass die-off unmatched by any other in the history of the planet, a cosmic reset button that clears the stage for an entirely new cast of characters. Yet, as devastating as this event will be in the short term measured in mere thousands of years, it would paradoxically ultimately clear the field for a whole lot of evolutionary diversification. The very space left by the vanished would create immense opportunities, a vast open playing field for new forms of life to emerge, to experiment, and to eventually dominate. And chief among the beneficiaries of this colossal tragic clearing will be a group of agile, adaptable reptiles that would one day, for a glorious span of time, rule the planet, the dinosaurs. Our alien scientists, with their immense foresight, might even sense the gathering storm, the impending shift, a subtle tremor in the cosmic fabric. Though the full scale of the catastrophe would remain hidden from their gentle gaze, let us now trace our path forward through that 100 million year gap we previously acknowledged, a period of profound quietness in our alien observers' cosmic journey. Unbeknownst to them during that silent interval, Earth had endured its deepest wound, a scar that would forever redefine the very course of life. They missed what we call the Permian-Triassic Extinction Event, a catastrophic moment in planetary history that occurred approximately 252 million years ago. Imagine, if you will, the gentle unraveling of a vast, intricate tapestry thread by precious thread until only scattered fragments remained. This was no gentle thinning of the ranks. It was a devastating purge, a planetary reset on a scale never before or since witnessed. Our leading theory, a whispered narrative pieced together from ancient rocks and fossilized echoes, points towards a culprit far grander and more insidious than any single impact: immense, prolonged volcanic eruptions. Imagine fissures opening in the Earth's crust, not as isolated volcanoes, but as vast gaping wounds spewing forth unimaginable quantities of material for hundreds of thousands of years. We see the geological fingerprints of this catastrophe in what we call the Siberian Traps, an enormous region in modern-day northern Russia. Here, vast flood basalts, cooled flows of ancient lava stretch for thousands of square kilometers deep, in places a silent testament to the raw, unbridled power unleashed from deep within the Earth. These were not mere eruptions. They were supervolcanic events on an unprecedented scale, each pulse unleashing enough power to reshape continents. These relentless eruptions and unending planetary exhalation would have released a truly staggering amount of carbon dioxide into the atmosphere. Picture the sky growing heavy, choked with this invisible gas thickening the Earth's insulating blanket to an unbearable degree. This colossal influx of greenhouse gases would have rapidly, mercilessly raised global temperatures, creating a searing, humid heat that few organisms could endure. Imagine the world becoming a vast, suffocating greenhouse, the air growing dense and unbreathable for many. The sheer volume of CO2 would have triggered a runaway warming effect, turning temperate zones into blistering heat traps and pushing polar regions towards unfamiliar warmth, disrupting delicate global climate patterns. But the devastation didn't stop in the air. As the immense amounts of carbon dioxide dissolved into the vast Panthalassic Ocean, a silent, insidious change began to unfold. The oceans, those vast cradles of life, became increasingly acidic. Imagine dropping countless invisible drops of acid into a colossal bathtub, slowly, irrevocably changing its very chemistry. This acidification, a quiet deadly poison, was particularly devastating for marine life, especially those organisms that relied on calcium carbonate to build their shells or skeletons, like corals, mollusks, and countless forms of plankton. Their very building blocks began to dissolve, their protective homes melting away. This catastrophic chain of events, the searing heat, the poisoned air, the acidifying oceans, eradicated life with a terrifying efficiency. Approximately 70% of all terrestrial vertebrate species were wiped out forever. their ancient lineages abruptly severed. In the vast, once teeming oceans, the devastation was even more profound. A staggering 80% of all marine species perished, leaving behind vast empty niches. Imagine the silent, ghostly remains of entire ecosystems, once vibrant and complex, now reduced to an eerie stillness. It was a mass die-off unmatched by any other in the entire history of our planet. A biological trauma of unimaginable proportions, truly earning its somber title as the Great Dying. The world in the wake of this cataclysm would have felt strangely empty, filled with an echoing silence where the symphony of life once played. Yet, as devastating as this event was in the short term, measured in mere thousands of years, it paradoxically profoundly shaped the future. It would eventually clear the field for a whole lot of evolutionary diversification. Imagine a vast overgrown forest suddenly cleared by a colossal fire. While the immediate aftermath is one of desolation, it also creates open ground, abundant sunlight, and new opportunities for different kinds of plants to sprout and flourish. The massive biological vacuum left by the Permian-Triassic extinction created immense opportunities, vast empty niches, ready to be filled by any creature resourceful enough to survive the initial onslaught. New forms of life once suppressed by the established dominance of Permian creatures now had room to experiment, to adapt, to proliferate without the weight of ancient competition. And chief among the beneficiaries of this colossal tragic clearing will be a group of agile, adaptable reptiles that would one day, for a glorious span of time, rule the planet, the dinosaurs. While their earliest ancestors already existed during the Permian, they were small, unassuming, and lived in the shadows of the synapsids like Dimetrodon. But the extinction event, with its sweeping devastation, eliminated their primary competitors, leaving the stage open. This wasn't an instant coronation. It was a slow, gradual ascendancy, as these early dinosaurs, with their unique physiology and adaptations, began to slowly, cautiously fill the newly vacated ecological roles. They were the inheritors of a world remade by catastrophe, poised to embark on their own incredible evolutionary journey. Our alien scientists returning to Earth during the late Jurassic period, approximately 150 million years ago, would still be oblivious to the precise details of the Great Dying they had missed. Yet the world they now observe is a testament to the profound shifts that followed. They would immediately notice that Pangaea, that single unifying supercontinent they had seen forming, was beginning its slow, majestic process of drifting apart. Although Pangaea managed to hold together until the early Jurassic, the relentless unseen forces of tectonic movements within the planet's lithosphere had begun to pull it asunder. The Earth, as they would perceive, is made up of about 15 to 20 massive tectonic plates, colossal rafts of solid rock floating on the semi-molten mantle below. These plates are always in motion, endlessly grinding towards or away from each other at a rate so imperceptible to us, yet so powerful over geological time. Imagine them moving at roughly the same slow, steady rate as our fingernails grow, about 1.5 centimeters a year. This seemingly tiny movement, accumulated over millions of years, leads to monumental changes. As these colossal plates slowly move away from each other, they open vast rifts in the Earth's crust, like unseen zippers, slowly unzipping a colossal garment. Along these rifts, molten basaltic lava continuously wells up from the mantle, creating new crustal material. So beginning around 200 million years ago, the northern part of Pangaea, known as Laurasia, began its majestic separation from the southern part, Gondwana. This grand divorce created two smaller, though still immense, supercontinents. In the north, Laurasia contained what would eventually become modern-day North America and Eurasia. To the south, Gondwana included the ancestral landmasses of South America, Africa, Australia, India, and Antarctica. A narrow body of water, the Tethys Sea, was also opening up a slender blue ribbon, gradually widening between the separating landmasses. This ancient sea would one day grow into the vast North Atlantic Ocean as the continuous outpouring of basaltic lavas at the mid-Atlantic ridge continued to push the continental landmasses farther and farther apart, like a colossal slow-motion conveyor belt, creating new seafloor. Meanwhile, in the south, what would become Antarctica and Madagascar had begun their slow, deliberate separation from the African continent, opening up the Proto-Indian Ocean. Our alien visitors, with their long-term perspective, would already have an inkling of where Earth's continental configuration was heading, recognizing the embryonic shapes of the continents we know today, subtly emerging from the ancient fracturing supercontinent. It was a dynamic, ever-changing dance of land and sea, a testament to the ceaseless geological forces at play. The climate of the Jurassic period, in stark contrast to the previous icehouse conditions, and even the brief warmth of the early Triassic, was scorching hot. Global temperatures were a staggering 5 to 10 degrees Celsius warmer than they are today, painting a picture of a humid, almost tropical world, even at high latitudes. The atmospheric carbon dioxide levels were approximately 4 times greater than present-day levels, acting as a powerful greenhouse gas, trapping immense amounts of solar radiation. What contributed to all this CO2, our alien scientists might muse. Very likely, the massive extinction of plants during both the Permian-Triassic extinction event and a subsequent, though smaller die-off, called the End-Triassic extinction played hefty roles. Fewer plants meant less CO2 being absorbed from the atmosphere, allowing it to accumulate. Additionally, increased volcanic activity, perhaps linked to the continental breakup, would have continued to pump CO2 into the air. Global temperatures were so warm that ice sheets were completely unable to form at the poles. Instead, the poles, far from being barren white wastes, were covered in lush forests. Imagine ancient woodlands thriving in regions we now associate with permafrost and perpetual ice, likely experiencing warm extended summers and cool snowy winters, but never succumbing to true glaciation. With so little water locked up in glacial ice, sea levels were significantly higher than they are today, reaching a peak right around this time, about 140 meters higher than present levels. This meant vast swathes of what are now coastal plains and low-lying continental interiors would have been submerged, creating extensive shallow seas, perfect nurseries for marine life. In terms of flora, the plant life that now dominated the terrestrial landscape presented a vibrant tapestry. Gymnosperms, such as conifers, had become one of the most successful plant types, forming vast forests that spanned continents. Imagine towering ancient evergreen trees, their needles shimmering in the warm, humid air. Some trees, like the extinct Araucaria mirabilis, represented by remarkably well-preserved cones, found in the fossil record, look eerily similar to what you might find in certain parts of the world today, a testament to their enduring evolutionary success. This was also a golden age for cycads, palm-like vegetation, with woody cylindrical trunks and stiff pinnate leaves resembling ancient sturdy palms. These plants grew heartily in the late Jurassic's expansive tropical and subtropical climate zones, forming dense, verdant undergrowth and providing abundant food for the emerging herbivorous giants. As our alien scientists, with their gentle observational approach, stepped out of their ship onto this vibrant Jurassic Earth, a deep, resonant rumbling would have vibrated through the very ground beneath their articulated limbs. Looking over the horizon, their multifaceted eyes would spot a pack of towering sauropods moving like living mountains across the landscape. Not just any sauropods, but perhaps Supersaurus, one of the most massive terrestrial animals in Earth's history, a true leviathan of the land. Imagine a creature stretching up to 35 meters long, its immense neck reaching impossibly high into the ancient sky and weighing a colossal 40 metric tons. These were living, breathing monuments to the abundance of the Jurassic world, their colossal footsteps leaving deep impressions in the soft earth. Overcoming their initial fright at the sheer scale of these magnificent creatures, our alien visitors would quickly realize that these Goliaths were in fact herbivorous grazers, gentle giants well adapted for reaching high vegetation. their long necks allowing them to browse on the loftiest leaves of the cycads and conifers. But their relief would be short-lived. Stalking some of the smaller sauropods, moving with an eerie predatory grace, would be a lean, rangy Allosaurus, a formidable species of carnivore. This powerful predator, nearly 10 meters long with dozens of needle-sharp serrated teeth, was the undisputed apex hunter of its time, a true terror of the Jurassic. Luckily, our alien visitors, with their advanced technology and innate caution, would quickly escape their brush with the hungry carnosaur and wisely decide to finish the rest of their tour from the safety of their ship, observing from the air where the grand drama of predator and prey could unfold beneath them. Once safely in the air, soaring above the ancient forests, they would encounter another marvel of Jurassic evolution, a feathered Archaeopteryx. This creature, often considered one of the first true birds, represented a pivotal moment in the lineage of avian dinosaurs. Imagine it a creature with delicate feathers, but also a toothed beak and clawed fingers on its wings, a living bridge between the reptilian past and the avian future. The Archaeopteryx was also sharing the skies with large flocks of non-avian pterosaurs, such as the graceful Dimorphodon, with its large head and short neck, and the crested Pterodactylus, famous for its elongated head crest. These winged predators, with their leathery wings and toothy beak-like jaws, were well adapted for catching smaller animals and invertebrates gliding effortlessly on the warm Jurassic air currents. The skies were no longer just for insects. They were a dynamic, vibrant realm teeming with flying reptiles and nascent birds. But as our alien scientists paused their expedition for a quiet lunch in one of the more sheltered forest glades, it wasn't the colossal dinosaurs or the graceful flyers that captured their attention next. It was something small and unassuming emerging from a burrow in the undergrowth that truly caught the xenzoologist's interest again. A tiny furry creature scurrying cautiously through the dappled sunlight. This was Tailhardina and other members of the extinct order, multituberculates, named after their unusual complex teeth, which they used in a forward and back grinding motion perfectly adapted for chewing tough plant material. These were some of the earliest mammals, small, discreet, and often nocturnal living, literally under the feet of the colossal dinosaurs. While they may have looked unassuming, resembling modern rodents or shrews, our aliens quickly realized that there was something profoundly different about them. As they observed their quiet sociability, the gentle way they interacted, and the playful manner in which they engaged with one another, a deeper understanding began to dawn. These little rodent-like creatures, with their relatively highly developed brains, especially compared to the pea-brain dinosaurs, possessed a crucial evolutionary advantage. They were warm-blooded, capable of regulating their internal temperature. This was a significant adaptation, allowing them to remain active in varying temperatures, unlike their cold-blooded reptilian overlords. Furthermore, they possessed a useful insulating adaptation called fur, a soft, downy coat that helped them maintain their warmth in a fluctuating environment. Little did our alien visitors know, the great descendants of these humble scurrying creatures would one day outlive the mighty dinosaurs, inherit the Earth, and ultimately come to dominate the planet, shaping its future in ways unimaginable during the Jurassic. But that chapter, the story of the mammal's ascendancy, will have to wait for a return trip by our intrepid travelers. They are worn out from the scrapes and scares of this journey, from witnessing the raw power of ancient predators to the quiet revolution of tiny furred beings. Yet they certainly leave with a profound sense of Earth's immense diversity and astonishing adaptability. Who knows, they may indeed come back to finish the story another day, perhaps, even to meet the distant progeny of those tiny furry creatures, and marvel at the incredible journey that life has taken on this ever-changing, ever-surprising blue marble. Let us now, with a gentle, patient breath, rewind our cosmic clock slightly, stepping back just a little from the vibrant, dinosaur-filled Jurassic world we just explored. Our alien scientists, those meticulous historians of cosmic unfolding, are keenly aware that the story of Earth is rarely linear, often punctuated by surprising detours and profound turning points. Having learned of the mighty dinosaurs' emergence, They now seek to understand a pivotal, yet often overlooked chapter in their ascendancy. They are now focusing their gaze on Earth during what we call the Carnian pluvial episode, a remarkable period around 230 million years ago. This was a time when a seemingly ordinary geological event triggered a cascade of changes that profoundly reshaped life and set the stage for the dinosaurs' dominance. Imagine our time-traveling aliens hovering just off Pangaea's west coast in what is now modern-day Canada. As they arrived, a subtle shift in the atmosphere began, then strengthened, signaling the start of something extraordinary. Epoch-ending volcanic activity from deep within the Earth's mantle, specifically linked to what we now call the Rangalia Large Igneous Province, began to send off a profound chain of events. This was no ordinary eruption. It was a planetary sigh that all but made the ensuing remarkable transformation inevitable. The world, particularly its vast arid interior, would never look the same again, because this was the start of a reign that wouldn't abate for over 1 million years. Yes, a reign that changed the very course of life on Earth. A reign that allowed the dinosaurs to truly take over the world in an evolutionary coup. What's all the more surprising, both to us and to our alien observers who have witnessed life on Earth develop through countless trials, is that the kind of event that caused this persistent epoch-defining reign is ordinarily associated with the most reliable and powerful extinction events the world has ever known. Typically, massive flood basalts bring widespread death and desolation. But this one was different. This was a subtle yet profound dance of cause and effect, one that takes the butterfly effect to its very limits. Imagine if a butterfly flapping its wings could cause a tornado 1,000 miles away. What then, our curious observers might ponder, does an eruption 100 times larger than a mere supervolcano cause? The answer in this specific case was not just destruction, but also a fertile ground for new life. Let's gently rewind further. Just before this great reign began to understand the world that preceded it, Pangaea was, as we've discussed, the largest continent that has ever existed on Earth, an unbroken expanse of land that dominated the planet's surface. Its immense size meant that its very center was thousands of miles removed from coastal climates, far from the moderating influence of the vast ocean. Consequently, this colossal interior received very little rain, creating a vast arid desert landscape. This dry period, stretching back to around 300 million years ago into the Carboniferous period, naturally favored the evolution of species that required less water to survive. Those hardy pioneers adapted to a parched existence. Throughout this dry spell, several species emerged that are still ecologically important today, or represent ancient lineages that would lead to them. Imagine vast forests of primitive plants forming the coal seams we rely on today, and among them, the scuttling forms of dragonflies, millipedes, and spiders, reaching sizes unfamiliar to us now. More significantly during this period, the diapsids truly exploded in diversity. This was a crucial group of reptiles containing lizards and snakes. But more importantly, for our story, the archosaurs. You may not know that name instantly, but you certainly know what this pivotal group contains: crocodiles, birds, and, yes, eventually, the mighty dinosaurs. They were the silent players moving in the background, subtly evolving, waiting for their moment. If you've gently followed our previous episodes on ancient Earth, you'll know that it has always been a tumultuous and unforgiving place, with impending threats lurking left, right, and center, and indeed, above and below, while asteroids smashing into the crust often grab the attention of our human stories and Hollywood narratives, generating dramatic explosive spectacles. It is often deep under the crust where the real insidious danger has always resided. And it is here in the slow, powerful movements of Earth's interior that we will find the answers to what caused a million-year storm. We live on a vanishingly thin crust, a fragile eggshell of rock that covers the vast, churning interior of our planet. This crust is so shallow that if the Earth were represented by the entire Lord of the Rings book trilogy, the thin, life-harboring layer containing all the known life in the entire universe, would be confined to just one single page. Beneath this delicate surface, immense, superheated plumes of rock slowly, majestically rise up from the fiery core mantle boundary, like colossal, unseen columns of heat. As they ascend, they mushroom, spreading out beneath the thin crust, pushing molten magma up against its underside. These huge plumes, unlike the neatly aligned volcanoes we see today along continental fault lines, like the famous Pacific Ring of Fire, punch through the crust wherever they meet it, completely ignoring existing geological weaknesses. This means they can emerge anywhere like unexpected boils on the planet's surface. These plumes can then release an unimaginable volume of magma at the surface for over 1 million years in what are known as flood basalt eruptions. It is these very eruptions, these slow, persistent outpourings of planetary blood, that are linked to the most incredible extinction events during Earth's history. They are probably the root cause of the most destructive extinction event in all of planetary history, the Great Dying. The Permian-Triassic extinction we just discussed, where ocean temperatures soared to 40 degrees Celsius, pushing life to its absolute brink. While life undeniably possesses an astonishing ability to evolve and adapt, it is estimated that over 99% of every species that has ever lived on Earth has ultimately gone extinct. Of course, you can't exactly evolve out of the way of a Mount Everest-sized asteroid, traveling at 20 kilometers per second, but these volcanic processes, though slower and far less dramatic in their immediate impact, can cause far greater devastation over a longer, more insidious period, subtly poisoning the air and sea. Evidence of this vast ancient flood volcanism is scattered across the world today. Silent monuments to Earth's deep fiery past. The immense eruptions of these flood basalts result in the creation of huge, unmistakable swaths of land, like the Siberian traps in northern Russia, the Deccan traps in western India, and crucially for our current story, the Wrangellia Large Igneous Province, Slip, across what is now Canada and Alaska. They are all cooled flows of basalt rock kilometers deep, making them over 100 times larger than even the most powerful supervolcanoes we know. When we gently date these colossal flood basalts, we see that many of these monumental eruptions align almost perfectly with major mass extinction events acting like geological timestamps of planetary trauma. There is one, however, that doesn't quite fit the typical pattern of pure devastation. That, our gentle listeners, is our Rainmaker event, the one that triggered the so-called Carnian pluvial episode CPE, or the time that it rained for over 1 million years. It's widely believed that the prolonged volcanic activity in the Wrangellia province is primarily responsible for this remarkable transformation, shifting an arid desert into a vast oasis that in turn jump-started the dinosaurs' ecological explosion. So what separated Wrangellia's eruption from the rest? What made it different? Well, I've got quiet news for you. Size does matter, but in a nuanced way. Although this was indeed an extinction event, with around 30% of the ocean species wiped out during the CPE, the Wrangellia eruption was perhaps paradoxically just the right size to give life an overall boost on Earth, rather than a crippling blow. So the reason that the overall biodiversity when looking at the entire planet was largely unchanged is because the level of extinction was precisely matched, and in some cases overshadowed, by the emergence of new exciting species more suited to this weather changing world. What our aliens witnessed was less a pure extinction event and more a reinvention period, a grand reshuffling of the deck of life where old forms gave way to new, better adapted ones. So how can a slow, prolonged eruption affect such an incredible global change to Earth's climate? To understand how this transformational event gently shuffled the deck of life on Earth, we must turn our thoughts to something we are living through right now: climate change. Specifically, we must consider the release and production of carbon dioxide and the release of stored methane. These two greenhouse gases, invisible but profoundly powerful, hold the key to understanding ancient climate shifts. Eruptions like these directly release immense amounts of carbon dioxide already contained deep within the Earth's mantle, exhaling them directly into the atmosphere, a deep fiery breath from the planet's lungs. But they can also trigger its release from other stores too, from sources of carbon that one might have thought only humans had the power to unlock. Imagine vast ancient reservoirs of fossil fuels buried deep beneath the Earth's crust, laid down hundreds of millions of years before in swampy carboniferous forests. Now, whether you remember the basic concept of the fire triangle from school, fuel, heat, and oxygen, I think we can all gently appreciate that introducing 1 to 600 degrees Celsius magma to the base of untapped virgin coal beds is going to get spicy. The intense heat from the rising magma plumes literally cooked these crude coal beds, causing them to release enormous quantities of particulates and additional greenhouse gases, including more CO2 and methane, into the atmosphere. These released gases and tiny airborne particles were both important for driving cloud formation and sustained rainfall. Just as we are seeing today, the increasing levels of those greenhouse gases trap more of the sun's energy within Earth's atmosphere, and that trapped energy has to go somewhere. So, where does it go? The complex Earth systems work tirelessly to distribute that extra energy, and the one best place to absorb this surplus energy is the water cycle, which becomes profoundly supercharged. Imagine the water cycle as a giant energetic engine. The sun's energy is absorbed by the land and sea, evaporating vast quantities of water from the surface. Once in the atmosphere, this water can be carried great distances by vast air currents before condensing and precipitating onto land, eventually returning to the sea along a meandering route of rivers and streams. The more energy that is trapped by greenhouse gases, the faster and more intensely the water cycle turns over, leading to increased evaporation, more cloud formation, and ultimately, more widespread precipitation. In these flood basalt eruptions, we see an extreme example of the complex interplay of the three major Earth cycles: the geological cycle constantly reshaping the land, the carbon cycle governing the flow of carbon between Earth's reservoirs, and the water cycle endlessly moving life's most precious liquid. The formation of the Rangelia Large Igneous Province would have released truly huge amounts of CO2. Our alien ship with its sophisticated atmospheric sensors would have detected atmospheric levels exceeding 1,000 parts per million, a staggering 2.5 times what they are today. This immense increase in greenhouse gases would have directly increased global temperatures by 3 to 4 degrees Celsius, a profound warming that pushed the planet into a new, hotter equilibrium. This supercharged the water cycle, greatly increasing evaporation from the vast Panthalassic Ocean and fueling massive cloud formation. And these clouds, heavy with moisture, were increasingly able to deliver rain further and further into the very center of Pangaea, transforming its once arid heart into a green, thriving landscape. Throughout this period, the Earth became warmer and more humid, a dramatic, pervasive change in climate that rippled through every ecosystem. Species that had painstakingly adapted to a particular dry climate environment or niche before the Great Rain were now put under immense stress from multiple fronts during this profound turnover period in Earth's history. Our aliens watched as old niches were seemingly destroyed as quickly as the new ones were created. The existing status quo was changing fundamentally, forcing adaptation or extinction. Not only that, but species also had to cope with a profound pH shift in their environments. Carbon dioxide wasn't the only gas released by the Rangelia eruption. Hydrogen sulfide gas, with its distinct pungent egg-like smell, also erupted into the atmosphere along with it. This noxious gas reacted with oxygen and water to form sulfuric acid, which in this form is more commonly known as acid rain. As this pervasive acid rain fell, the soils and oceans became increasingly inundated with acidified water, which only further contributed to the immense environmental stress many species were facing. Imagine the delicate balance of ancient ecosystems slowly being eroded by this corrosive downpour. Interestingly, a large amount of amber can be found in the geological record from the Carnian pluvial episode. Amber is a protective mechanism for trees, a sticky resin that they release when under severe stress or in peril. This abundance of amber suggests that plant life too came under significant stress during this period, fighting to survive the altered atmospheric and soil chemistry. The incredible volume of persistent rain across the supercontinent resulted in vast deluges of surface runoff, accelerating across and through the once arid terrain. The slightly acidic flows of water relentlessly eroded the land as they went carving new channels and shaping the landscape in profound ways. Some of this acidic water seeped into the ground, slowly dissolving and eroding small fissures in limestone and dolomite rocks. Our aliens watched as entire sections of rock were literally dissolved in front of their eyes, a silent, slow chemical transformation. Over time, elaborate new cave systems were formed like Britain's Tassoc Caves, carved patiently from ancient Carboniferous limestone, which in turn provided yet more unique sheltered habitats for life, to exploit new dark sanctuaries for those seeking refuge from the relentless surface changes. Eventually, the endless flow of eroded rocks and minerals reached the sea, carrying its dissolved load into the vast Panthalassic Ocean, further nudging the coastal ecosystems into new, often challenging territory. The ocean species were particularly hard hit during this period, especially those sensitive to acidity and oxygen levels. Large areas became anoxic, meaning they lacked oxygen, turning vast stretches of the sea into silent, barren zones. These anoxic and highly acidified conditions were not suitable for the existing marine ecosystems that had inhabited those areas. Species like conodonts, ammonoids, bivalves, and certain forms of green algae suffered particularly high extinction rates during the CPE. Conversely, tiny dinoflagellates, which are a constituent of today's ocean planktons, thrived in these new challenging conditions, rapidly colonizing the altered waters. Our aliens on their ship might have quietly moaned in disbelief every time the ship's AI forecasted the ongoing miserable weather, the endless rain observing the profound impact on the planet's vast blue expanse. But back on land, while the ocean struggled, a quiet revolution was taking place. One of the oldest known dinosaurs, Herrerasaurus, was braving the elements and roaming the earth. This early predator, some 6 meters in length and weighing more than 300 kilograms, was an outlier of formidable presence. Prior to the Carnian pluvial episode, smaller reptiles and mammals were far more numerous, dominating the terrestrial landscape, but the Herrerasaurus's home was the Ishkigualasto Formation, a volcanic floodplain defined by its dense jungle in what is modern-day South America. It was already a warm and humid environment, one to which the Herrerasaurus was well adapted. So when the pervasive rains began to fall across Pangaea, the Herrerasaurus and its early dinosaur relatives won a kind of geological lottery. Their preferred habitat, these warm, humid, well-watered regions, began to spread across Pangaea, advancing deeper and deeper into the continent's interior. These spreading areas became literal oases, vast untouched habitats where the extinction of other less adaptable herbivores and competition meant it was to be a boom time for the Herrerasaurus and similar early dinosaurs. Imagine vast new territories, opening up rich with resources and free from the former ecological gatekeepers. We can only imagine the variety and richness of habitat suddenly available for all these wandering species to find and exploit, to expand into, and to co-evolve with over time, slowly, steadily solidifying their foothold. Further away in the Dolomites of what is now Europe, the aliens saw herds of large dinosaur creatures roaming the plains, their wandering footsteps leaving indelible marks. Their passage, their slow, deliberate march across the ancient landscape, has been remarkably recorded deep in the rock across a 3 to 4 million year period, spanning the Carnian pluvial episode. The fossilized footprints tell a compelling story. Dinosaurs went from not featuring at all in the fossilized footprints to ecological dominance, making up over 90% of all fossilized imprints. This was a truly remarkable takeover, a silent coup that agrees perfectly with other fossil records found in other parts of Pangaea during this time period, notably the Central European Formation and the Ixigualasto Basin in Argentina. The story was consistent, the world was changing, and dinosaurs were rising. The 2-million-year period, spanning the Carnian pluvial event, left its indelible mark in profound ways, forever changing the trajectory of life on Earth, as well as the passage of water across and through its surface. The megamonsoonal climate featured 4 distinct intense downpours, each lasting hundreds of thousands of years, each carving a profound trace through the landscape. This made the biblical storm that remade the Earth in 40 days and nights look more like a typical British summer in comparison. But the 5th period of rain never came. Once the Rangelia eruption finally slowed, the emission of greenhouse and acid-forming gases subsided, and it is likely that levels of carbon dioxide in the atmosphere slowly fell as it was consumed by the rich flora that now covered Pangaea. Some of this abundant plant matter, in a deep historical irony, would again become buried slowly, patiently, forming the vast coal and fossil fuel deposits that we much later would come to use, continuing the grand slow carbon cycle of the planet. Now the storm has passed and the world has been reshaped. We can, with a quiet sense of understanding, answer our profound question. If a butterfly flapping its wings can cause a tornado 1,000 miles away, what does an eruption 100 times larger than a supervolcano cause? Well, a complete terraforming of land, sea, and air. The aliens left having witnessed the origin of the dinosaurs' dominance, a silent, profound shift in the balance of life. They understood that Earth's story is one of continuous, often dramatic transformation. Some 180 million years after this profound event that gave dinosaurs their big break, another even more sudden cataclysm would strike, wiping them from the face of the earth. For the earth giveth, and the earth taketh away in its own slow, patient, and often dramatic rhythm. From that point, it has been the mammals who have come to dominate, including us humans, a remarkable reminder both times of how much can change on a geological whim, and that at each moment of asking as the rules of the world change, life adapts, finds a way and goes again. Now let us continue our journey forward, gently carried by the vast currents of time, leaving behind the profound, rain-drenched transformation of the Carnian pluvial episode. Our patient alien scientists, those quiet chroniclers of Earth's grand narrative, have set their sights on a period roughly 150 million years ago, a time we call the Late Jurassic period. They are eager to witness the magnificent culmination of the dinosaurs' rise, to see the world shaped by these colossal creatures, the true giants of their age. As they approached even from a great distance, the most striking geographical change would be immediately apparent. Pangaea, that immense unified supercontinent, was no longer whole. While it had bravely managed to hang around more or less intact until the early Jurassic, the ceaseless unseen forces of tectonic movements within the planet's lithosphere had finally begun their irresistible work, slowly but surely pulling it apart. Imagine a colossal ancient masterpiece, meticulously crafted over eons now, subtly, gracefully beginning to fracture along predetermined lines. The Earth, as our alien observers would perceive, is not a static, unchanging sphere. Instead, its solid outer shell, the lithosphere, is made up of about 15 to 20 massive, irregular tectonic plates. These colossal rafts of solid rock float not unlike immense icebergs upon the semi-molten churning mantle below, and they are always endlessly in motion, grinding towards or slowly drifting away from each other. The pace of this majestic dance is so imperceptible to our fleeting human lives, yet so profoundly powerful over geological time. Imagine them moving at roughly the same slow, steady rate as our own fingernails grow, about 1.5 centimeters a year. This seemingly tiny continuous movement, accumulated over millions upon millions of years, leads to truly monumental changes, reshaping continents and opening vast oceans. So beginning around 200 million years ago, a grand continental divorce commenced. The northern part of Pangaea, known as Laurasia, which contained what would eventually become modern-day North America and Eurasia, began its majestic separation from the southern part, Gondwana. This colossal parting of ways created two smaller, though still immense, supercontinents. To the north, Laurasia slowly drifted, shaping itself into the early forms of the northern landmasses we know. To the south, Gondwana, still a vast entity, included the ancestral landmasses of South America, Africa, Australia, India, and Antarctica. It was a slow, inexorable splitting, like a colossal piece of ancient parchment being gently, gradually torn in two. A narrow body of water, the Tethys Sea, was also opening up a slender blue ribbon, gradually widening between the separating landmasses. This ancient sea, born from the fracturing supercontinent, would one day grow into the vast North Atlantic Ocean, its waters expanding as the continuous outpouring of basaltic lavas at the mid-Atlantic ridge continued to push the continental landmasses farther and farther apart. Imagine a colossal slow-motion conveyor belt relentlessly creating new seafloor, pushing the continents apart with an unseen primordial power. Meanwhile, in the south, what would eventually become Antarctica and Madagascar had begun their slow, deliberate separation from the great African continent, opening up the Proto-Indian Ocean, laying the nascent groundwork for the continents as we know them. Our alien visitors, with their long-term perspective and vast knowledge of planetary dynamics, would already have an inkling of where Earth's continental configuration was heading. Recognizing the embryonic shapes of the continents we know today, subtly emerging from the ancient, fracturing supercontinent. It was a dynamic, ever-changing dance of land and sea, a testament to the ceaseless geological forces at play, endlessly sculpting and reshaping the face of our world. The climate of the Jurassic period, in stark contrast to the previous ice-laden conditions, and even the brief, if intense, warmth that followed the Great Dying, was scorching hot. Global temperatures were a staggering 5 to 10 degrees Celsius, warmer than they are today, painting a picture of a humid, almost universally tropical world, extending its warm embrace even to high latitudes. The atmospheric carbon dioxide levels were approximately 4 times greater than present-day levels, acting as a powerful, pervasive greenhouse gas, trapping immense amounts of solar radiation within the atmosphere. This dense, warm blanket ensured a pervasive heat. What contributed to all this excess CO2, our alien scientists might muse. Very likely, the massive extinction of plants during both the Permian-Triassic extinction event and a subsequent, though smaller die-off called the End Triassic extinction played hefty roles. Fewer plants meant less CO2 being absorbed from the atmosphere, allowing it to accumulate. Additionally, increased volcanic activity, perhaps linked to the energetic continental breakup, would have continued to pump vast quantities of CO2 into the air, contributing to this planetary fever. So profound was this global warmth that ice sheets were completely unable to form at the poles. Imagine regions that today are synonymous with perpetual ice and snow entirely devoid of frozen water. Instead, the poles, far from being barren white wastes, were covered in lush forests. Picture ancient woodlands thriving in regions we now associate with permafrost and perpetual ice, their canopies thick with foliage, likely experiencing warm, extended summers and cool, snowy winters, but never succumbing to true glaciation. With so little water locked up in glacial ice, sea levels were significantly higher than they are today, reaching a peak. Right around this time, a remarkable 140 meters higher than present levels. This meant vast swathes of what are now coastal plains and low-lying continental interiors would have been submerged, creating extensive shallow seas, perfect nutrient-rich nurseries for marine life, fostering new ecosystems beneath the warm, vast waters. In terms of flora, the plant life that now dominated the terrestrial landscape presented a vibrant, diverse tapestry. Gymnosperms, such as conifers, had become one of the most successful plant types, forming vast forests that spanned continents, their ancient forms reaching skyward. Imagine towering ancient evergreen trees, their needles shimmering in the warm, humid air, their cones heavy with seeds. Some trees like the extinct Araucaria mirabilis, represented by remarkably well-preserved cones found in the fossil record, look eerily similar to what you might find in certain parts of the world today, a testament to their enduring evolutionary success and the timeless beauty of their form. This was also a golden age for cycads' distinct palm-like vegetation, with woody cylindrical trunks and stiff pinnate leaves resembling ancient sturdy palms. These plants grew heartily in the late Jurassic's expansive tropical and subtropical climate zones, forming dense, verdant undergrowth and providing abundant food for the emerging herbivorous giants that would come to dominate the land, a lush, endless banquet for the colossal diners. As our alien scientists, with their gentle observational approach, stepped out of their ship onto this vibrant Jurassic Earth, a deep, resonant rumbling would have vibrated through the very ground beneath their articulated limbs. The air itself might have pulsed with a low-frequency hum, a subtle tremor indicating the presence of immense forces. Looking over the horizon, their multifaceted eyes would spot a pack of towering sauropods moving like living mountains across the landscape. These were not just any sauropods, but perhaps Supersaurus, one of the most massive terrestrial animals in Earth's history, a true leviathan of the land, its sheer scale almost defying belief. Imagine a creature stretching up to 35 meters long, its immense neck reaching impossibly high into the ancient sky browse the treetops, and weighing a colossal 40 metric tons. These were living, breathing monuments to the abundance of the Jurassic world. Their colossal footsteps leaving deep impressions in the soft earth, each step a mini earthquake in itself. Overcoming their initial fright at the sheer scale of these magnificent creatures, our alien visitors would quickly realize that these Goliaths were in fact herbivorous grazers, gentle giants well adapted for reaching high vegetation. Their long necks and immense bulk allowing them to access the loftiest leaves of the cycads and conifers. They were the great cultivators of the ancient forests, their endless hunger shaping the very vegetation around them. But their relief would be short-lived. Stalking some of the smaller sauropods, moving with an eerie predatory grace, would be a lean, rangy Allosaurus, a formidable species of carnivore. This powerful predator, nearly 10 meters long with dozens of needle-sharp serrated teeth, was the undisputed apex hunter of its time, a true terror of the Jurassic, a creature perfectly designed for the hunt. Its roar would have echoed through the primeval forests, a chilling sound of ancient predation. Luckily, our alien visitors, with their advanced technology and innate caution, would quickly escape their brush with the hungry carnosaur, and wisely decide to finish the rest of their tour from the safety of their ship, observing from the air, where the grand drama of predator and prey could unfold beneath them, a silent, breathtaking spectacle of survival. Once safely in the air, soaring above the ancient forests, they would encounter another marvel of Jurassic evolution, a feathered Archaeopteryx. This creature, often considered one of the first true birds, represented a pivotal moment in the lineage of avian dinosaurs, a living testament to the ongoing evolution of flight. Imagine it a creature with delicate feathers, beautifully adapted for gliding, but also possessing a toothed beak and clawed fingers on its wings. A living bridge between the reptilian past and the avian future, a creature still holding on to echoes of its ancient lineage while embracing a revolutionary new form. The Archaeopteryx was also sharing the skies with large flocks of non-avian pterosaurs, those magnificent winged reptiles. Among them, they might observe the graceful Dimorphodon with its large head and short neck, perhaps soaring over the ancient coastlines, and the crested Pterodactylus, famous for its elongated head crest and long slender wings. These winged predators with their leathery wings and toothy beak-like jaws were well adapted for catching smaller animals and invertebrates gliding effortlessly on the warm Jurassic air currents. The skies were no longer just for insects. They were a dynamic, vibrant realm teeming with flying reptiles and nascent birds, a chorus of wings beating against the ancient sky. But as our alien scientists paused their expedition for a quiet lunch In one of the more sheltered forest glades, a moment of unexpected revelation awaited them. It wasn't the colossal dinosaurs or the graceful flyers that captured their attention next. It was something small and unassuming, emerging cautiously from a burrow in the undergrowth that truly caught the zoologists' interest again. A tiny, furry creature scurrying cautiously through the dappled sunlight, a hidden whisper of a future yet to come. This was tailhardina and other members of the extinct order Multituberculates, named after their unusual complex teeth, which they used in a forward and back grinding motion, perfectly adapted for chewing tough plant material. These were some of the earliest mammals, small, discreet, and often nocturnal living, literally under the feet of the colossal dinosaurs, a hidden lineage patiently biding its time. While they may have looked unassuming, perhaps resembling modern rodents or shrews, our aliens quickly realized there was something profoundly different about them. As they observed their quiet sociability, the gentle way they interacted with their offspring, and the playful manner in which they engaged with one another, a deeper understanding began to dawn. These little rodent-like creatures, with their relatively highly developed brains, especially compared to the pea-brained dinosaurs, possessed a crucial evolutionary advantage. They were warm-blooded, capable of regulating their internal temperature independently of the environment. This was a significant adaptation, allowing them to remain active in varying temperatures, including the cooler nights, unlike their cold-blooded reptilian overlords who relied on the sun for warmth. Furthermore, they possessed a useful insulating adaptation called fur, a soft, downy coat that helped them maintain their warmth in a fluctuating environment, conserving their precious metabolic heat. Little did our alien visitors know, the great descendants of these humble scurrying creatures would one day outlive the mighty dinosaurs, inherit the Earth, and ultimately come to dominate the planet, shaping its future in ways unimaginable during the Jurassic. They were the quiet, hidden champions, carrying the seeds of a new era within their tiny forms. But that chapter, the full story of the mammal's ascendancy, will have to wait for a return trip by our intrepid travelers. They are worn out from the scrapes and scares of this journey, from witnessing the raw power of ancient predators to the quiet revolution of tiny furred beings. Yet they certainly leave with a profound sense of Earth's immense diversity and astonishing adaptability. They have seen worlds within a world and the ceaseless capacity of life to find a way. Who knows, they may indeed come back to finish the story another day, perhaps even to meet us, the distant progeny of those tiny furry creatures, and marvel at the incredible journey that life has taken on this ever-changing, ever-surprising blue marble. The vastness of time and the endless capacity for transformation remain the most profound mysteries, inviting us to simply wonder. Welcome back to our alien tour of Earth's history, where we gently reconstruct what prehistoric Earth might have looked like over millions and billions of years. For those just tuning in, our quiet premise remains. Imagine that alien scientists are visiting Earth at various stages in its development, simply observing, wondering, and trying to comprehend the grand unfolding of this remarkable blue marble. In our previous journeys, our alien voyagers covered a vast swathe of Earth's timeline from its fiery birth, 4.5 billion years ago, through its molten infancy, its eventual cooling, the emergence of the first humble organisms, and the great oxidation event that so profoundly shaped its atmosphere. They swung by during the Cambrian period to witness an explosion of species diversity across our planet's ancient oceans, and landed in the Devonian period, some 360 million years ago, to see life taking its first tentative steps onto land. Then, in our last chapter, they marveled at the Jurassic period, some 150 million years ago, a world utterly dominated by colossal dinosaurs like Supersaurus, while tiny furry tailhardina whispered of a future yet to come, and Archaeopteryx circled above. Today, our patient alien scientists revisit Earth, some 84 million years later, utterly oblivious to the dramatic, cataclysmic changes that have occurred on this now dramatically different planet. They are perhaps expecting to see the same lush green world still run by the likes of Allosaurus and Brachiosaurus, the familiar rhythms of the age of dinosaurs. What they are about to witness, however, is one of the most famous and profound events in Earth's history, the dinosaur extinction. We will examine the leading theories of what caused this mass extinction and what kind of indelible impact it had on the animals who were around to witness it. For the last tens of millions of years, every time our alien friends flew over Earth, they'd seen a lush green world, a vibrant tapestry of life run by the likes of colossal Ceratosaurus, towering Barosaurus, and agile Eoraptor. Life from their perspective seemed stable, flourishing, and eternal in its grand reptilian forms. Let's imagine our alien explorers, with their gentle curiosity and scientific precision, decide to descend and collect samples of this incredible world on a certain day 66 million years ago. But first, they need to make a quick pit stop. Their ship is running low on helium-3, a rare and precious fuel source, and they decide to swing by Jupiter, that gas giant in our outer solar system, to refuel. Without this vital source of power, their ship won't be able to take off again once they land on Earth. They agree with a quiet hum of their engines that they'll come back tomorrow to begin their detailed exploration. When they return the very next day, a mere cosmic blink, they perform their routine check of their GPS or galactic positioning system. A ripple of confusion passes through their silent craft. They must have made a mistake, they ponder. This cannot be the same thriving planet they flew over just yesterday. The world beneath them, once a vibrant tapestry of green and blue, is now an utterly unrecognizable spectacle of devastation. There is no way their sensors confirm that the fiery, scarred globe covered in a choking shroud of smoke and ash is the same flourishing planet. Our alien friends are utterly flabbergasted, their profound understanding of planetary stability momentarily shattered. What in the deepest reaches of cosmic possibility could have happened in such a short span of time to cause such utter devastation? The Earth they came back to is covered in raging wildfires, vast infernos consuming 70% of its ancient forests, their smoke rising in colossal plumes that darken the very sun. Gigantic tsunamis, waves reaching up to a kilometer high, roar across continents, pushing vast walls of water far inland, carving new landscapes of destruction. It is an immense, inescapable death, a new brutal reality that has set in, one that would consume the planet for the next couple of decades. The air itself is thick with choking dust and ash, a silent, pervasive killer. No familiar sign of life remains, only the raw, brutal aftermath of an unimaginable cataclysm. To find out what happened, let's gently jump forward in time, stepping into the shoes of our own human scientists to see what they have discovered about this profound planetary wound. The story begins in the 1980s when two human scientists, Walter and Luis Alvarez, made a truly monumental discovery. They detected the presence of a rare chemical element called iridium in the geological record, precisely at the point in time where the mighty dinosaurs mysteriously disappeared from the fossil record. This boundary, a thin distinctive layer of clay, is known as the Cretaceous-Paleogene, or KPG boundary. Not only that, but this specific iridium-rich ring has been consistently found at the KPG boundary in samples taken from around the entire world, from deep ocean cores to ancient land formations. It seemed like something had deposited an immense planet-wide amount of iridium all over the Earth's crust at the very same moment the dinosaurs went extinct. The curious thing is that iridium is usually pretty hard to come by on Earth's surface. It's much more abundant deep within our planet's core or in certain extraterrestrial objects. Yet these particular rock layers at the KPG boundary contained 200 times the amount of iridium we would normally expect to find in Earth's crust, a startling anomaly. Can you guess, our gentle listeners, where iridium is particularly abundant in the cosmos? In asteroids. This observation, a quiet whisper from the ancient rocks, began to suggest a truly monumental cosmic impact. But if such a catastrophically large asteroid did indeed crash down to Earth, surely it would leave behind a colossal crater, one that would be pretty hard to miss. Well, just a few years later, human scientists found that too. Known today as the Chicxulub crater, it lies off the coast of the Yucatan Peninsula in Mexico, hidden mostly beneath ancient sediments and the Caribbean Sea. It spans a whopping 200 kilometers in diameter, a vast circular scar on the planet's face. After meticulous testing, researchers confirmed the age of the crater as being about 66 million years old, lining it up exactly with the iridium anomaly in the KPG boundary and the abrupt disappearance of dinosaurs from the fossil record. The pieces of the puzzle were gently, inexorably falling into place. Another core piece of evidence that quietly, powerfully supports the asteroid theory is something called tektites. These are small, dark, glassy objects, often teardrop or dumbbell-shaped, that have been found in abundance in several places around the world at the KPG boundary. One of the most astounding discoveries came from North Dakota, USA, thousands of kilometers away from the Chicxulub crater. Researchers found a fossilized mass grave there, an incredible snapshot of a moment of devastation frozen in time. It contained fish, charred tree trunks, conifer branches, mammals, mosasaur bones, insects, and even the partial carcass of a triceratops, all perfectly preserved together along the KPG boundary. Scientists had never seen such a collection of diverse organisms at different life stages, who all died at the exact same moment. And intertwined among all these fossils were countless tektites and microspherules, tiny glassy beads. The leading theory, a powerful and compelling narrative, is that these tektites and microspherules are actually pieces of molten Earth crust superheated by the force of the impact. They were shot up into the sky on impact with such incredible force that they left the atmosphere, cooled into natural glass in the vacuum of space, and then inevitably rained back down onto the Earth in a fiery global glass shower at speeds of 160 to 300 kilometers per hour. And remember, North Dakota is 3,000 kilometers away from the impact site. Imagine the sheer unimaginable force required to propel molten rock that far, and the terrifying spectacle of glass falling from the sky like hot, deadly rain. So let's gently gather this evidence together and paint a picture for our alien travelers, those patient observers of what could have happened to Earth while they were quietly filling up on gas near Jupiter. As our extraterrestrial explorers turned their back to Earth for that brief interval, they might have noticed something remarkable. An asteroid perhaps 10 to 15 kilometers wide, about the size of a small mountain, would have been accelerating towards the planet, growing brighter and bigger against the immense blackness of space, traveling at an astounding speed of 72,000 kilometers per hour. It would have been an unstoppable force of nature, a cosmic bullet aimed directly at our world. Then, with an unimaginable deafening roar, it makes contact just off the shore of the Yucatan Peninsula of modern-day Mexico. This single cataclysmic strike instantly releases an insane amount of energy, all at one go, concentrated in a single terrifying point. The equivalent energy of detonating billions of nuclear weapons, at the same time a burst of power beyond human comprehension. This was an earthquake felt around the entire globe, a colossal tremor that would have rippled through the planet's very core. There's no way such an event went unnoticed, even by animals on the other side of the planet in modern-day Indonesia, who would have felt the ground buck and heave. At the immediate impact site, the thermal radiation, a wave of incandescent heat, would have instantly vaporized and burned everything within a 1,500-kilometer radius. The sheer force of the impact from the asteroid made the Earth's crust go molten, splashing up like water. After a pebble has been dropped into a pond only on a planetary scale, this colossal splash left behind a monstrous crater, an immediate wound, 25 kilometers deep and 100 kilometers wide, a raw exposed basin of incandescent rock. This impact immediately caused a chain reaction of enormous tidal waves, hundreds of meters high, as the ocean was violently pushed back from the immense force of the strike, then surged back in obliterating coastal regions. Meanwhile, trillions of metric tons of debris, about 60 times the mass of the original asteroid itself, exploded upwards into the atmosphere, a colossal plume of pulverized rock and vaporized material, reaching beyond the atmosphere and into space. Some of this debris, those infamous chunks of molten Earth crust high in the atmosphere, would cool and coalesce into tektites, and inevitably, what goes up must come down. For about 15 minutes following the initial impact, Earth was covered in a torrential storm of fire rain. Falling debris heated to hundreds of degrees Celsius as it screamed through Earth's atmosphere, ignited a global inferno. This set the world on fire, burning down 70% of its forests, turning lush landscapes into smoldering desolation. Vaporized material that didn't rain down as fiery debris, such as fine silicate dust from shattered rocks, stayed suspended in the atmosphere, along with unbelievable amounts of soot and carbon dioxide rising from the global wildfires. If you're breathing a quiet sigh of relief, for our Indonesian dinosaur friends, those who are on the apparent other side of the planet, don't. Like with most great calamities, it's never merely the actual impact that leads to the most widespread devastation. It's the insidious aftermath, the colossal buildup of gases and fine particle debris in the atmosphere. That global shroud of dust and soot effectively blocked out the sun. This sudden prolonged darkness plunged the planet into a chilling impact winter that would last at least 15 years, perhaps even longer. With no sun, plants were utterly unable to photosynthesize, robbing the base of the food chain of its energy. Both terrestrial and marine food chains collapsed in a horrifying domino effect, starving creatures on land and in the sea. Earth became a totally apocalyptic version of its former glory, a cold, dark, silent world. No wonder our alien travelers had to check their GPS. The planet was utterly unrecognizable. The impact this would have had on animal life would have been utterly devastating. A staggering 75% of all species on Earth were wiped out forever, their diverse forms vanishing from the planet, making this one of the largest mass extinction events in Earth's history, second only to the Permian extinction we covered earlier. All the animals that exist on Earth today, including us, are the distant descendants of the survivors of this apocalypse, a testament to the immense power of resilience. Others were not so lucky. Being large, it turned out, was a profound disadvantage in an apocalypse. Large creatures like the mighty dinosaurs needed vast amounts of food, lots of space, and abundant resources. When these suddenly vanished, they faced immediate, insurmountable challenges. All terrestrial and marine dinosaurs, save for one lineage, suffered greatly and eventually died out as a result of the collapse of ecosystems and the harsh new climate. However, a small sliver of avian dinosaurs, what we now call birds, had better luck. They managed to slink through this evolutionary bottleneck, that narrow, perilous passage of survival, into the Paleogene period. They still roam the Earth today, those direct descendants, a living echo of the dinosaurs' mighty past. When we think of birds, we typically think of beaks. But back in the Cretaceous days, birds came in all kinds of different wonderful variations that we've never seen with our own eyes. Some had beaks, some didn't. Some had teeth, some didn't. While it would be foolish to credit a single trait for the survival of an entire family line in such a complex event, it sure seems that if you were a bird 66 million years ago, having beaks stacked the odds in your favor. We think that beaked birds had a crucial advantage. They could dig out seeds from the ground when no other food source was available, a vital skill in a world of scarcity. Toward the end of the Cretaceous, beaked birds were already eating a more varied diet than their non-beaked cousins, a generalist approach to foraging. This dietary flexibility would have been a huge advantage when rations were scarce after the impact. After all, being a picky eater in an apocalypse isn't really a good idea. Having enough force in the gizzard to crush tough fruits and seeds, and enough flight stamina to gather food over large distances, also helped with survival, allowing them to exploit dispersed resources. Some species of mammals also managed to push through this perilous bottleneck. It is thought that only mammals smaller than 10 centimeters, those tiny, unassuming creatures living in the shadows, survived the immediate aftermath. Their small size allowed them to hide underground in burrows, where they were somewhat insulated from the plummeting global temperatures and the fiery rain above. Being small also meant they needed far less food to survive a critical advantage when every morsel was precious. The platypus, that unique egg-laying mammal, is an example of a mammal whose ancient ancestors coexisted with dinosaurs, survived the KPG extinction, and whose lineage is still around to this day, a living fossil of resilience. Turtles also fared surprisingly well, maintaining a remarkable diversity, although it isn't completely understood why about 80% of the known turtle species made it through the KPG extinction, as did crocodiles. While we can't be 100% sure why these particular groups survived, some ideas are that crocodiles, like beaked birds, have highly diverse diets, making them adaptable. Crucially, they can survive without food for more than a year, thanks to their excellent energy conservation abilities and slow metabolisms. A remarkable survival strategy in a world where food had vanished. Following the immense catastrophe, the repopulation of Earth seems to have happened remarkably fast, a testament to life's relentless drive to recover. If our alien scientists were to fly over Earth just 30,000 years later, a blink in geological time, they'd already see flourishing new ecosystems rising from the ashes in some parts of the planet. Perhaps it was for the best that our alien crew was low on helium-3 and didn't have to witness the apocalypse firsthand, but only its profound, eerie aftermath. Revising our version of events, our alien friends are not entirely convinced this is the full story. They are good scientists and better skeptics, understanding that complex phenomena often have multiple layers of causation. Just because the evidence paints one picture doesn't mean it can't also paint another, perhaps more nuanced one. Indeed, that is the exact conundrum we Homo sapiens find ourselves in now. While many human scientists hold firmly to the asteroid theory as the primary driver, others think differently, suggesting other profound forces were at play. Let's rewind the tape and re-examine the evidence, allowing for other possibilities. The initial clue that started all this asteroid business, remember, was that pesky element iridium. While it is indeed present in asteroids in high concentrations, it is also present in another key place, the Earth's core. This gives weight to another popular theory, that crazily strong prolonged volcanic eruptions could be the primary culprit behind the mass extinction instead. In this scenario, the world would still be covered by a blanket of smoke, soot, and debris, just as in the asteroid impact. Tephra and other volcanic ejecta would rain down, and the sun would be blocked out for years, causing a super long winter and total ecosystem collapse. And our iridium would still make it into the geological record, brought up from the mantle by the colossal eruptions. The effects are largely the same. The only difference is the root cause. So, is an asteroid or volcanoes to blame? There is compelling evidence showing massive volcanic activity during the late Cretaceous, around the time of the KPG event, specifically linked to the Deccan Traps in modern-day West India. Researchers say that the presence of vast flood basalts from such eruptions corresponds with 3 out of the 5 major mass extinctions in Earth's history, including the one that nearly claimed all life during the Permian Triassic. Flood basalts are left behind when massive areas of land are rapidly flooded with lava, leaving behind step-shaped igneous rock formations called traps. The Great Permian extinction our alien friends witnessed, caused by the Siberian traps, was triggered by volcanic eruptions. Some scientists think the same thing happened to the dinosaurs, leaving its fingerprints in the Deccan Traps. Data shows this region was highly active at the time of the dinosaur extinction, continuously erupting for hundreds of thousands of years. A violent, sustained eruption would have had far-reaching global effects, filling the atmosphere with dust, toxic sulfur, and vast quantities of carbon dioxide gases, causing a wipeout in a similar way to the asteroid theory. Through climate change, acid rain, and prolonged darkness, Indeed, supercomputer simulations have shown that there is an incredibly strong correlation between flood basalt events and mass extinction events, a correlation much higher than pure chance. However, some scientists don't think it is an either-or situation, but a complex intertwined story. A growing body of research is trying to reconcile a both-and version of events, suggesting that the impact of the asteroid and the subsequent earthquakes and seismic waves it generated potentiated the ongoing volcanic activity, pushing it over a lethal threshold and into mass extinction territory. Perhaps the impact triggered intensified volcanism, or perhaps the existing volcanic stress made the planet more vulnerable to the asteroid's strike. But the exact extent to which each event played a role in the ultimate demise of the dinosaurs is still up for quiet debate, a puzzle that human scientists continue to unravel with patient curiosity. I hope this exploration of possible theories is enough to satisfy our alien scientists. By now they've seen Earth in enough of its forms, from a molten ball of lava, to a pale orange wasteland, to a giant snowball, to a flourishing tropical world, to a vast supercontinent, and now to a planet scarred by cosmic impact and volcanic fury. They have witnessed its resilience, its adaptability, and its profound capacity for transformation. If there is one thing they can truly rely on in Earth's story, it is transience. Earth won't be a ball of fiery rain and eternal winter forever. It's just a matter of time before life springs up again, tenacious and adaptable, reshaping the world anew. Who knows what they'll see on their next flyby, or what forms life will take. Thanks for joining this profound, quiet journey through Earth's planetary evolution. Are you interested in learning more about Earth's history in future episodes, perhaps looking at the rise of mammals, or even our own story? Which part of Earth's history would you like to visit if you could? Please let me know in the quiet comments below, and let your dreams drift towards the next chapter of this incredible saga.